Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon, good morning, and good evening to all of the participants across the world. First of all, I would like to thank all participants for joining the IEEE Young Professionals Machine Learning Summit. This summit is organized by IEEE Young Professionals Malaysia in collaboration with the Space Science and Engineering Research Group, Universiti Teknologi MARA, Pasir Gudang Campus. I am Rufada Osman from University of Malaysia's Faculty of Medicine, Department of Orthopedic Surgery, and my research is in tissue engineering with a particular emphasis on regenerative medicine, and I will be the MC for the day. This summit is live on Zoom. It is recorded and will be uploaded to the IEEE Young Professionals Malaysia YouTube channel. And dear participants, please share your name, institution or organization, location, and current time zone in the chat box so we know where you are from. Also, don't forget to share your professional social network account such as LinkedIn for networking purposes. For your information, at the end of each talk, we will open for a Q&A session. So if you have any questions regarding the discussed topic, you can type your questions in the Zoom chat box. Before we begin our main agenda for today, I would like to invite Muhammad Zulkarnain to lead the recitation of Tilawah Al-Quran and Dua recitation. Join me in welcoming Muhammad Zulkarnain. All right, I think we have a bit of technical issues, so we might have to proceed straight to the next agenda. All right, are you ready, ladies and gentlemen, to take your knowledge to the next level? Then let me introduce you to the objectives of this summit. The first objective of this summit is to provide you with the latest technological trends and knowledge that will advance technology for humanity. And our second objective is to give local members like you an international platform to learn, inspire, and give back to your community. The third is to provide you with an excellent opportunity to expand your global network. And last but not least, this summit aims to increase awareness among non-IEEE members on the benefits of being part of the world's largest professional organization. So get ready to discover how IEEE membership can help you grow your career, connect with global professionals, and access exclusive resources. Ladies and gentlemen, I am delighted to introduce Young Berusaha IR Dr. Nordin Ramli, the chair of IEEE Malaysia section, to deliver the opening speech. And before he takes the floor, I'd like to provide a brief overview of his portfolio. IR Dr. Nordin Ramli currently serves as the chair of IEEE Malaysia section and also holds the position of head of technology management, specializing in research at NIMOS Berhad. He received numerous accolades, including the Top Research Scientist Malaysia TRSM Award in 2018 and the Young Scientist Award, YSM Award by the Academy of Sciences Malaysia in 2014. And in 1999, he obtained his Bachelor of Engineering degree in Electrical Engineering from Keio University from Japan, and his Master of Engineering and PhD degrees in Electronic Engineering from the University of Electrocommunications in Japan back in 2005 and 2018, respectively. With over 2 decades of experience in the telecommunications industry, he has worked in research and development roles and previously served as a network engineer at Telekom Malaysia Berhad from 1999 to 2008 and a lecturer at Multimedia University Malaysia from 2008 to 2009. Currently, as head of technology management at NIMOS Berhad, he is responsible for the technology strategy, research portfolios, and R&D project management. Please welcome Young Berusaha IR Dr. Nordin Ramli.
Can you hear me?
Yes, we can hear you very clearly.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon, everyone. First of all, I'm Nordin Ramli. I'm from the IEEE Malaysia section as a chair. First of all, I'd like to thank you for all the participants for this IEEE YP Machine Learning Summit. As the sections, we would like to happy that support this program, and we have a lot of speakers coming from many places, and definitely as a big group of the members in Malaysia, the YP able to support conduct this program and so on. We will feel very timely and is in line with what is happening in the world. Just a little bit give you some overview of the IEEE Malaysia. IEEE Malaysia has members about at February last year, we have about 3,100 members, and out of that, YP members is about 1,110, which is consists about 40% of the members. So it means that YP is the main driver, the big stakeholder within IEEE Malaysia. As the technology evolve, you can see that machine learning become very important, and this is very right approach taken by the YP Malaysia to organize this event. So I'm very glad that we have many speakers coming from local, but Sarah, Dr. Sarah Iqbal, Dr. Stephens, Dr. Madiati Muhammad Yunus, Dr. Felipe Benevas, and Dr. Azmi Linda, that will providing you the talks as well as some elaboration about the topics. As much we look forward to have more events like this, and therefore we will discuss further with the YP group. What more important, actually, we want the benefits to the members, and this is one of it, and we can do it through the online. I would like to also congratulate the YP Malaysia, because they won various award last year. Among others, they have been selected to be in the YP Hall of Fame, so which is very rare, the award that been given to YP Malaysia. Okay, I think that's all from me. I would like to thank you for all the speakers, as well as all the organizing committee that's work tirelessly to prepare for this event. And I also wish all the audience best, all the best in this event. All right. So from IEEE Malaysia, we always support and look forward to have more events like this. By that, thank you.
Thank you, Young Professionals IR Dr. Nordin Ramli, for the opening speech, gracing us with your remarkable words of wisdom for this remarkable event. And with that, we would like to take a group photo with all of the speakers, and to include our virtual attendees in the photo, we encourage everyone to turn on your cameras and strike a pose for a screenshot. Right, I think everyone is ready. Right, I think there are 4 panes here. I think I can see Ms. Luna Arlifa. Please turn on your camera if that is possible. Thank you, Mrs. Devi Dumanasari, for turning on your camera. Right, please prepare yourself and try to make a freestyle position. Right, we are going to take the photo now. When I count down from 3, please make sure your camera is turned on and pose a smile for the camera, okay? All right, ready for the first pane? Here we go, 3, 2, 1, smile. Very nice. And the second pane, smile, 3, 2, 1. All right, nice. Okay, we go to the third pane. 3, 2, 1, smile. All right, I think this is the fourth one. All right, 3, 2, 1, smile. All right, thank you so much. All right, thank you to the esteemed speakers and the attendees for your kind cooperation. We will now resume the program. So ladies and gentlemen, let's continue our summit with a sharing on IEEE membership. She is Mrs. Sarah Iqbal, an executive committee member of the IEEE Young Professionals Malaysia. Mrs. Sarah Iqbal completed her master's degree in computer science from Comsats University, Islamabad, Pakistan in 2009, and subsequently worked as a lecturer at King Khalid University, Abha, KSA for 10 years from 2009. Currently, she is pursuing a PhD at the Faculty of Computer Science and Information Technology, Universiti Malaya, with research interests focusing on IoT, vehicular communication, fog computing, and machine learning. Sarah has been an active member of IEEE since 2018 and was selected as the IEEE Young Professional Ambassador in 2021. She was also chosen as the IEEE PACE Day 2022 Ambassador under the IEEE Malaysia section. Let's give a warm welcome to Mrs. Sarah Iqbal for the talk in being an IEEE member.
Thank you, Ms. Rafeda, for this introduction. I am Sarah Iqbal, as MC introduced me. Thank you very much for providing me this opportunity to talk about IEEE. I have recently finished my PhD from Universiti Malaya in computer science, and I am part of Executive Committee IEEE YP Malaysia. I also done graduation from IEEE 2022 World Program, which is a volunteer leadership training program. So today I'm giving an introduction about IEEE and the benefits of IEEE. The very first question which people ask is, why should we join IEEE? I'm going to address this question. And secondly, there are people who are already member of IEEE, but they are somehow unaware of the potential of this membership and unaware of the benefits they can have. So let's start our presentation. My presentation includes introduction, then I will provide a brief history. We will see IEEE at a glance, the IEEE current leadership, membership grades, and the membership benefits. To begin, in simple words, IEEE is the world's largest association of technical professionals. And membership in this global community brings number of benefits that give you a professional edge. We have members from academia, government, and industry who help make IEEE the world's largest publisher of technical content. IEEE stands for Institute of Electrical and Electronic Engineering, but IEEE is not limited to electrical and electronics engineer. This is one of the misconceptions. I'm from computer science and I'm proudly a part of IEEE and find it quite beneficial. Nowadays, especially in research, from research point of view, the disciplines are so much interrelated, and the latest research is multidisciplinary. So as the tagline says, advancing technology for humanity, so almost all the technical research which involves the development of humanity comes under IEEE. A brief history. In 1884, the American Institute of Electrical Engineer was found, and Norman Green was the first president. Later in 1912, another society named Institute of Radio Engineers was formed. In 1962, it was proposed to merge these two societies. So officially on 1st January 1963, IEEE was born with 150,000 members. Now, IEEE represent its members reside in 159 countries besides United States. As you can see, geographically, IEEE is distributed among 10 regions. And we, as a part of IEEE Malaysia sections, represent region 10. IEEE has over 400,000 members all around the world, which makes it one of the largest professional organizations. IEEE leadership for 2023, Professor Saifur Rahman is the current president and CEO, whereas Professor K.J. Ray Liu was the past president. Dr. Thomas is the president-elect for 2023. Now, the first question is how to get involved with IEEE. You can connect with IEEE locally through members, affinity and special interest groups, student communities, and humanitarian activities. IEEE has 39 technical societies. You can join the one related to your own field. 7 technical councils, they are a broader group dealing with several societies at a time. IEEE has 22 technical communities, and as an IEEE member, you can join any technical community for free. It has 4 affinity groups. What IEEE does? IEEE organize conferences, publish journal articles and periodicals, and have technical societies, which are the focus group on specific discipline. These are the technical societies. As an IEEE member, you can choose the technical society of your interest and be part of that society to meet the people of same interest and expertise. As you can say, it involves ComSoc, Computer Society, and Photonic Society, etc. I'm not giving much details right now. You can find all the details later on through IEEE website. Then the technical councils. Technical council sponsors activities that benefit individuals in all members. These are the technical communities. If I'm from computer science, I can find the specific community of my interest, which can be smart grid, cloud computing, blockchain, software-defined network, etc. To understand the IEEE management, it is important to know the hierarchy, how IEEE operates. As we have discussed about regions, so let's talk about region 10. There are several sections under region 10, and we are representing IEEE Malaysia sections. Under sections, there are subsections, which are Malaysia have 3 subsections: Sabah subsection, KL subsection, Sarawak subsections. Then we have chapters. Chapters are under section and technical societies. There are affinity groups, which are Women in Engineering Affinity Group, Young Professional Affinity Group, Consultant Networks Affinity Group, and Life Members Affinity Group. Then we have student branches. Every university almost all universities have their representation through student branches. And then student branches have their student branch chapters and student branch affinity groups. Now comes the young professionals. Before discussing young professionals, if you are interested to join IEEE, you can join IEEE as a professional member or as a student member. Student member, you can be a student member or a graduate student member. The membership fee is same for both membership, but undergraduate join IEEE as a student member, whereas the postgraduate student join IEEE as a graduate student member. As a professional member, you can be a member, senior member, fellow, or life member, depending upon your years of experience and contribution. Now comes young professionals. As an IEEE young professional, graduate student member can join IEEE young professionals, whereas member and senior member can also be a young professional if they have graduated within the last 15 years. Something more about affinity groups: Women in Engineering Affinity Groups, Young Professionals Affinity Group, Consultant Networks, and Life Member. IEEE membership benefits. If I talk specifically about benefits, these are some of the free benefits. IEEE Collaboratech. It's a social platform where technology people can network and collaborate with each other, just like you can have an idea like a LinkedIn or ResearchGate. And then we have IEEE.tv. It is an internet-based television network delivering special interest program about technology and engineering for the benefits of IEEE and also for public. But IEEE member get the subscription free. It has many webinars and technical conferences available. Then we have ebooks. You can check the magazines: IEEE Spectrum, IEEE Potentials magazine, Today's Engineers. These are you can get the free subscription. Then also you can access the digital library, IEEE Explore. IEEE also offers you your personalized email address through Google Apps, where you can have your email address at IEEE.org. And all the Google services will be available. You can get special discount if you are attending any conference or publishing with IEEE. You can find jobs through IEEE platforms through job site. There are career alerts, IEEE career alerts. Then there are mentoring programs where you can find the people of same interest and share where they can share their experience and you can benefit from that. Then IEEE offers a resume lab, which help you improving your resume. Then there is a consultant database, a service available for matching technical consultant to clients. These are the discounts. These are the discounts where you have to pay some fee, but as a member, you will get a special discount. Either you are publishing in some IEEE Access article or somewhere in some other proceedings of the IEEE, or you can have travel services, etc. All the details of these discounts can be found on IEEE.org/benefits. So IEEE provide you an opportunity to stay updated technically through the magazine subscription like IEEE Spectrum, the Institute, the research articles through Explore, and ebooks. And IEEE Collaborative is a very good professional networking site where you can meet so many people of your interest. And it can help you in your career development through resume lab, mentoring sites, job sites, etc. So what IEEE give you? It gives you an opportunity to learn. You can contribute to IEEE as a volunteer. As a member, you can get benefit, but if you start volunteering with IEEE, you will get more benefits. And then you can influence the people around you, either fellow students or young professionals. So if you are interested to join IEEE, you can join as a professional, as a student. And you can, if you have any question, you can contact us. We are IEEE Young Professionals, and it is free of charge. You can approach us through Facebook or email us, follow us on Instagram and Facebook. Thank you very much for this opportunity. I hope you will get an idea about IEEE, and if you have any question, you can contact us anytime. Thank you.
Thank you, Mrs. Sarah Iqbal, for the informative content on IEEE membership. All right, ladies and gentlemen, let's proceed with today's IEEE Young Professionals Machine Learning Summit. If you have any questions during the session, please use the Zoom chat box. We'll read the questions at the end of the session. Now, it is our utmost pleasure to welcome our keynote speaker, Dr. Stephen Lotz. A bit on his background. Dr. Stephen Lotz is a space physics research scientist based at the South African National Space Agency facility in Hermanus. He obtained his PhD in physics from Rhodes University in 2012. Dr. Lotz holds a C2 rating from the National Research Foundation and is an extraordinary professorship at the Department of Engineering at Northwest University, NWU, in South Africa. The affiliation with NWU stems from a collaboration with the Multilingual Speech Technologies Research Unit, where the focus is on utilizing machine learning for scientific research. His research interests are in space weather, specifically on geomagnetically induced currents, solar wind magnetosphere coupling, and more broadly, machine learning and the interpretability of complex models. Kindly receive Dr. Stephen Lotz.
Good afternoon, everyone. Thank you for the great introduction, and thank you for inviting me to this talk, to give the talk. I'm just going to share my screen. Can someone just comment if my audio is okay? Is my mic level high enough? Can everyone see the screen?
Yes, it is clear from here.
Okay, good. Right, so as was mentioned, I have this dual or extra affiliation. So my main affiliation is with the South African National Space Agency. I just want to make sure, can you see my mouse? Would that be okay if I use that as a pointer?
Yes, we can see the mouse too.
Good. Okay, so I'm based at the South African National Space Agency facility in Hermanus. What that means is we measure the Earth's magnetic field. That's the easy summary of what we do. We measure the Earth's magnetic field and then try to estimate what's going on in near Earth space from that. This affiliation with the deep learning research group at Northwest University is really the focus of this talk, so the work we do with them specifically. And yeah, I'm just going to acknowledge my co-author here, Professor Margie Davel. She's a machine learning engineer at this university. The other affiliations here are with the South African AI Research Group, and then we have this grant from the National Institute for Theoretical and Computational Sciences, and I'll talk a bit about that right at the end of the talk. Okay, so what is going to happen in the next 45 minutes? Let me just set my timer. So I'll say something about space weather, just because this is the field I'm working in and where I'm applying this machine learning stuff. You guys are all engineers, so it shouldn't be difficult to grasp these concepts, even though you may not be familiar with them. I'll say something about deep learning and machine learning and where all these words fit into each other. You know, what's a neural network, what's AI, what's deep learning, that kind of thing. I'll then shift focus a bit to time series problems, because a lot of the stuff we see in kind of popular media has to do with the image-based applications of deep learning, and that's very nice and it's easy to understand. You know, give the machine a picture and it should tell you whether you're seeing a dog or a cat. We won't be doing that. We won't be focusing on that today. We'll talk about time series problems. And then from there, I'll go into interpretability and explainability. So that is a question that comes up once you have an accurate model. So once my model makes an accurate prediction, I want to know why did it make that prediction. If we can go back to let's say an example that gets quoted often is in the banking industry. So the bank has some automated way of awarding a loan to a certain person, and that person wants to maybe go back to the bank and say, why didn't you approve my loan? I see someone says my voice is unclear. I'm going to fiddle with my mic a bit. Is it better or worse now?
I think it's fine from here. So far, it's good.
Okay. I can see two people complaining
Is it?
about the audio. But anyway, if it's okay. Okay, there's echoing. Right. Let me move my...
But so far, it's okay from here.
Okay. I'm just going to move my laptop a little bit closer to me. And then I'm going to reduce the mic volume a bit. Is that better?
Yeah, I think now it's better. Isn't it, everyone? Is it better? Okay, good. All right, I think we can proceed. Dr. Stefan.
Okay, perfect. Sorry about that. So where were we? Yes, we'll talk about explainability and interpretability. So not just have the machine make an accurate prediction, we want to know why it did that. And that is a really very difficult question and something that is really unsolved at this point. I'll show some applications of this in space physics, and then I'll talk a little bit about that research program that I mentioned, and then I'll focus on some resources that you guys can use at the after this. So some caveats. This talk is not exhaustive, so I'm not going to give a review talk that will cite all the latest research and all the great things that other people have done. There's a lot out there, and just check some of the resources I cite. There are much better resources out there than what will be covered in this talk. Also, I'm not a machine learning expert, so I'm coming from a physics background. I'm utilizing this in my field, and then maybe tinkering a bit. So we try to develop newer models or models that will specifically work for our specific case. And also the machine learning field is moving very fast. So if you look at this talk a year from now, or maybe 6 months from now, a lot of the things I may say now may not be valid anymore. So just note that this field at this point in time is moving very quickly, which makes it very exciting, but maybe a little bit tricky to follow what's going on. Okay, so space physics and space weather. I'm going to give a very short summary. You can follow on the numbered items here. So eruptions from the sun emits some electromagnetic radiation and charged plasma. These emissions take some time to arrive at Earth. So if it's moving at speed of light, so the EM radiation moves approximately at speed of light, from the eruption it takes about 10 minutes to impact the Earth's magnetic field. Other emissions take up to 4 days to arrive because it's physical volume of plasma moving. So the distance of this between the sun and the Earth is that vast. Now these perturbations or disturbances to the magnetic field of the Earth, we call it the magnetosphere, sort of the bubble around the Earth created by the Earth's magnetic field. These perturbations now are translated inward towards the Earth. So the inner magnetosphere, the ionosphere, which is the charged part of the atmosphere, so about 90 kilometers and up, and then all the way down to the ground. So what we measure as fluctuations of the Earth's magnetic field at ground level. So we see all these things happening. The interactions are extremely complex and non-linear. It's non-linear in time, it's non-linear in the ways it interacts. And currently there's a lot of data available with all the satellites measuring these things. So it's great for a kind of data-driven analysis. Why do we care about this stuff? Well, all these things that I mentioned has some kind of impact on different technologies. And because modern life means we are so reliant on these technologies, perturbations or outages of these technologies can cause some problems. So in terms of communication degradation, any radio signal is disrupted or affected by this. So specifically satellite communications, and then by extension, all kinds of military communications are affected. So these people are typically our clients when we are predicting these effects. Navigation outages, so your GPS unit in your phone or whatever needs to have communication with the GPS satellite, but if the atmosphere between you and the satellite is disrupted or affected by induced currents or plasma bubbles or whatever the case may be, there's going to be some issues with your navigation accuracy. Induced currents, so I work a lot on this kind of thing. So if you have the Earth's magnetic field fluctuating at ground level, you induce an electric field. That induced electric field in turn induces a low frequency current in a network of conductors that is grounded into the Earth, right? So that means power grids are affected and oil pipelines and communication pipeline networks as well. So there's a lot of work we do with industry, with government, with industry, military. A lot of it's focused on prediction and forecasting, and then sort of long-term risk analysis. So that's the kind of field that I'm busy working in. It's a lot of plasma physics. It's a lot of data analysis. It's a lot of coupled systems working together and talking to each other. So now, deep learning. What do we mean with that? The little equation at the top here is supposed to show how these things fit together. So when we say artificial intelligence, and note the way that the media uses these words interchangeably, and that they are not really interchangeable in that sense. Artificial intelligence just means that we try to mimic human intelligence by some kind of machine. So that can mean anything. That can mean just something looking up values in a table automatically or very quickly and providing an answer. That can be seen as artificial intelligence. So a lot of search and heuristics. So for example, the early chess robots, the only reason they could beat humans is that they had a massive catalog of all possible moves from every possible point. And the only reason the robot won or could be competitive with a human is that it can quickly look up what's the best move statistically and play that. So that's not, we call it artificial intelligence, but that's not intelligent in the way that we think about it, right? So there's no intuition, there's no experience. It's just looking up values in a table very quickly. So probabilistic systems fall into this, say, like Bayesian networks, for example. Now, machine learning is something a little bit different. So machine learning, you can see that as a subset of AI. That means we are learning from data. So there's no one wrote the rules down. There was no algorithm to say, this is the rules of the game, this is how you should play it. So instead of someone teaching you the rules of chess, imagine just watching thousands of chess matches on a recorded chess matches and making up the rules for yourself from the data. That's machine learning. So there's no hard-coded rules. Examples of that is decision trees, nearest neighbors methods, and then neural networks. That's just one way of doing machine learning. Now, when we say deep learning or neural networks, these days we're kind of using these two words interchangeably, where deep learning or deep neural networks just means large neural networks. And it's purely a function of technology. These days we have more computational power, so we can build bigger neural networks. So that means nonlinear activation functions, highly nonlinear modeling, and examples of that is the stuff we see every day now, MLPs, convolutional neural networks, temporal neural networks, that kind of thing. Okay, so taking a step back, when we say machine learning or deep learning, what do we mean with that? So this is a picture I used when giving public talks, just as a way to explain what's happening when you are training a neural network. So imagine you have a recorded music album and you also have access to the individual recordings of every member of the band. So you have access to the data here, to the input, you have access to the output, but you don't know what the sound engineer did in the middle, right? So people recorded stuff, something happened in between, and the result was this mixed album that gets now played on the radio, right? So machine learning is essentially listening to the individual artists, listening to the output, and twisting these knobs to try and arrive at something that sounds like the recorded album. That's a very simple explanation of what machine learning does. So you want the model, you want the machine to learn the settings on the sound disk that results in the final recording, given these inputs, right? So that's a very stupid way of explaining it. Something a bit more technical. If we write down just what a very small neural network is you have data at the input layer. It gets scaled by some activation function. So these little graphs I draw in the middle of the blocks, that's what we call an activation function. So every input gets scaled by whatever this function does to it. A weight gets applied, so that just means multiplication. So N01 gets multiplied by weight number 111, going from layer 1 to layer 2. So after every weight gets applied, the values get summed. So that's what we are writing down here. N01 and N02 gets multiplied by its weights, and some other function gets applied to it. This function G. We call that the activation function. You can see we went from something linear to something that's not exactly linear. So we call this what's it called? A ReLU function. So it's partly linear, right? And you just follow this recipe. So this is a very small neural network, 2 inputs, 1 hidden layer with 2 hidden nodes and 1 output, a node in 1 output layer. Simple enough. And we can write this thing down as this little sum and we get something out, right? So why is this so powerful? Firstly, we can expand it. We can add as many layers as we want. So it can be many layers and every layer can be very wide. So typically you don't only have 2 inputs, you don't only have 2 nodes in your hidden layer, and you don't only have 1 hidden layer. You have many hidden layers, millions of nodes, right? And now at least what I call the secret sauce. So the secret of making this thing work so well are these nonlinear activation functions. So this, as you can imagine, the sum on the left-hand side here gets very complicated when we have 1,000 nodes or 1,000,000 nodes, right? So essentially what happens in a mathematical sense is really that we are taking the input signal and decomposing it as a series of nonlinear sums of some kind of nonlinear function. And once you do that decomposition, you can get close to the output, the thing you are trying to predict. So when we are training a neural network, sort of a cartoon design of what happens is something like this, where you start with some random model. So if you remember this guy, we start with some random weights. So it means that these W values are all randomized, right? So start with some random weights, make a test prediction, see if the test prediction is good or bad. If the test prediction is not good enough, you adapt the weights, so change them in some way. There are many ways to do this, but these are basically optimization functions. Change the weights, test again, change the weights, test again until the error is small enough, and then you stop. So you start with something with randomized weights, and you end with something that may look a little bit more structured. That's what I tried to illustrate with the color differences here. So that's what the training cycle looks like, more or less. Right, so now moving to time series. Now, it's very simple to write down what we mean with a time series problem. Y equals f of x, that's simple enough, right? But now we have y at some kind of regular interval, so that's why it's a time series problem. So we measure at regular intervals, say there's n measurements, and we have a number of inputs. So the output may be current rainfall, and the inputs might be season, air pressure, whatever, different inputs. And so if we have k inputs, we have this matrix of input values, and each of them have some kind of time lag or time delay. This is where things get tricky. So in the simple case, this tau is just equals to t. So at the same time that we measure y, the value of, say, x1 has an influence on y. That's simple enough. But we know things can lag. So the weather or the air pressure of yesterday actually matters to what happens to the weather today, right? So there's some kind of lag. And then you can get more complex lag. So this is formally kind of what we mean with a time series problem. And there's a lot of assumptions that we make here. Most of them are basic things, that things can be interdependent, but we are going to assume that things are not stationary. So we can have something like almost like phase transitions, right? So things don't stay the same statistically throughout the evaluation of the problem. Okay, an example of this, I just wrote it down here. I'm not going to go into detail because it's going to take too long, but an example of a very simple problem that you can solve with a 2x2 neural network is something like this, where we measure the pressure in the solar wind, so the plasma coming from the sun. We measure that out in space, right? We measure the density and the velocity, which is basically pressure, right? And we say, what is the influence of that pressure on the size of the magnetosphere? Size of the magnetosphere just means the area of influence where the Earth's magnetic field dominates, right? So as that pressure of the solar wind increases, that magnetosphere on the day side is going to be pushed back. We know this, we understand this, right? At least in this field, we can measure these things, we know it, we understand it, and there's a very simple approximate equation to this. And this is a case where you have this time delay where the speed at which the solar wind moves determines when that parcel of plasma arrives and when that indentation to the magnetosphere is going to happen. So this is a case we have this complex time dependence. Okay, right. That was just a real world example from what we mean with this kind of time series. Now, what I said is that we're going to look at interpretability. So say we didn't know which parameters cause the magnetosphere to change in size. Say we had access to a whole bunch of them. How would we want to know? How would we know that it's the speed and the density that's causing this? This is where the interpretation comes in. So imagine that you have this very good neural network model and it's predicting the size of the magnetosphere perfectly, and you are supplying it with 20 input parameters: plasma pressure, density, speed, temperature, magnetic field, everything you can get your hands on. You dump into this model and it's giving you very good results. But now there's someone raising a hand. Should we take the question now or later?
I think we can proceed. Dr. Stephen Lotz, you can proceed with the presentation first. We will take the question and answer after you have ended your presentation.
It's fine either way, but yeah, okay, let's wait. Remember your question and then keep it to the end. Okay, so imagine you have this model, you have many inputs, you don't know which of the inputs is the one actually causing the thing you are trying to predict, right? So when these accurate predictions are not enough, we need to think about interpretability. So why was the decision made? Why was the prediction made in the way that it was? And there are many ways to go about this. So the first prize is just looking at the data, and by looking at the data, you understand enough about the problem, you just explain what's happening. That's great. But usually things are not that simple, right? Then you have kind of local and global explanations where you can build directly interpretable models. We'll cover that. Or kind of sensitivity analysis where you input very specific inputs to the model and then see what it does on the output side and try and explain what's going on in the model in that way. So there are many different ways to do this, and we won't cover all of them. I'll highlight a few in the next few slides. So directly interpretable models. I really like this idea. It's just very difficult to do. So one way to do this is by something called symbolic regression, where you start with a set of very simple equations, and by looking at the influence that simple equation has on the output, given the data, you can develop a more complex equation by iteratively adding and removing parts of an equation in order to arrive something that matches the output data. So in this case, the sign was added for the oscillating part, and then this trend was removed, and then we found a match with this oscillating data. So this is a way of iteratively building up a model, and what you get in the end is an equation that you can read off of the page. So that's really good to have that in the end, right? And some really cool examples of recent successes for this kind of method. So there's a derivation of Newton's law of gravitation just from planet trajectories. So all that was fed into the model is the ways the orbits of the different planets over a long time. And this model completely skipped Kepler's laws and arrived at an equation that looks like Newton's law of gravitation, for example. You can solve very complex fluid models in this way. So I'm giving all the citations here just at the end of the talk in the last slide. Complex fluid models, discovery of cell division triggers, so doing biology with that, so defining what actually causes cells to divide. There's a very interesting example where they looked at the Feynman lectures, so that's a famous set of lectures condensed into a volume of 3 volumes of textbook by Richard Feynman, famous physicist. And using an approach like this, they solved the first 100 equations in those lectures automatically, faster than the state of the art, using a method like this. So this is really powerful, and what you get out in the end is something that is inherently interpretable because we can all read the equation, right? Something a bit more closer to the neural network side, the machine learning side now, is when you build models that are designed for interpretation. So this is something I did with a master's degree student, where we simply divided a network of, like in this case, it only had 3 inputs and 1 output. We simply divided into these sub-networks of combinations of the 2. So input 1 and 2, 1 and 3, 2 and 3. And by reading, and we designed these special summary nodes, and by reading out the information flow from these nodes, we could really see which input parameter, which input feature was important at what point in time of the event. So looking at a geomagnetic storm, we could see which values in the solar wind was really the one that aided the prediction of the storm effect on the ground. Then you have this kind of post hoc or feature attribution methods, where that is similar to what I just said, where you have a model that looks something like this, where this F now is the neural network. So you know which inputs go in and you know what comes out, but you don't know what the model looks like exactly. So an in-between step can be where you just ask for a ranking of the inputs. So which of these set of inputs are the ones that are really important to my model? And this is, you can do this by kind of sensitivity or perturbation analysis. So this is a crude example I did. This was still in my PhD work, I think. Yes. So very simple. I just added, as I added the input, I started adding 1 input parameter at a time. And at every round of training of the model, I just marked the one that gave the best result. So in the first model, this guy gave the best result, so I keep it. Second model, this guy gives the best result, so I keep it. And as you are adding, so we don't add all the input parameters at the same time, we add them one by one by one. And in the end, you build up a model that only has the inputs that are important and not all the rest. So that's one way of doing it. Something a bit more sophisticated is called Shapley values, where it's something based on game theory principles. So actually out of economics, where you assign the relative contribution that each input has to the prediction. I'll get back to that. We've applied that recently with a student, and it works really well. So you assign, so every input parameter contributes in a sense to the prediction, and you can you can assign a value of every contribution of every input parameter. Looking at things a bit differently, you can look at the information flow through the neural network. So layer-wise relevance propagation, LRP, uses a Taylor decomposition to, once you have the output of your model, you can reverse these steps and see how the information flowed through the model. So, and eventually you arrive at the input parameter. So if you can see that a certain prediction, for example, say we had to predict whether the picture we see is a dog, and we look at the flow of information through the network, and in the end you arrive at the pixels around the ears of the dog, we can say that this machine decided that this picture was of a dog because it had pointy ears. So you can make these kind of explanations by looking at how information flows through the network. The way we've applied this a year or two ago, we are still busy operationalizing this model, is to predict whether a certain spot on the sun, so these little dark areas on the sun is usually where those eruptions that I talked about happen. So now the task was, can you predict which of these guys will result in an eruption in the next 24 hours? And we built a model that did this, but not only that, we also looked at which of the input parameters are the ones that contributed most to the prediction. And out of that, you can almost start to do a little bit of physics to say, well, it's the potential in the electric field around this area that made the model decide that there is going to be a flare in the next few hours. And in this case, this thing worked really well. Less than 24 hours later, the spot with the 90% probability resulted in a solar flare, and we measured it here on the ground. So we use these Shapley methods, the ones based on game theory and economics. What we're busy with currently is to build a geomagnetic index prediction model, and these things have been done a lot in the past. There's so many examples of these kind of models, but what we wanted to do is to see if we do the interpretation of the successful model, can we show what the difference in predictions are at low and at high latitudes? So what we know from solar physics is, or geomagnetic modeling, is that the mechanisms that cause a disruption at low latitude, because it sits on a different field line, we know the Earth's magnetic field looks like a dipole, right? The area sitting at closer to the equator, there's different mechanisms involved in causing a disruption at Hermanus, for example, than at a high latitude place, Abisko in Sweden, for example. And we wanted to see, can the model show what the effect, why this happens? I know from the physics which parameters in the solar wind is more important for Sweden than for South Africa. And we wanted to see if the model can reveal this out of the data. And it does look like it. We're not finished yet, but it does look like it works. Yeah, so just have the different sets of data, inputs and output, and we're going to develop this model that trains on both, or that predicts either one, the index at one station or at both, and we're going to try and predict the difference as well, just to see what happens. And we use these Shapley values again. So this is some of the first results. So this is my master student. She's busy finishing her thesis for submission. And this is what we see. So the second last graph here is the predicted and the measured output. So we try to predict that gray curve. Our prediction model gives out this pink curve. In this case, the predictions wasn't very accurate, but that's okay. We're looking at the interpretation at this time. So each of these ribbons is there's one ribbon per input parameter, and from this, looking at the value at each point in time, we can see whether that input parameter contributed positively, meaning it raised the prediction in amplitude, or contributed negatively, meaning that input parameter, for example, that there, contributed negatively, so it caused the prediction to be lower. And out of that, this is also something we are using in how to predict, using to interpret which of these input parameters are important, in which way, and when during the storm. So this is one geomagnetic storm. You can see in the first part of the event, almost all the inputs have some kind of influence. During this middle part, some of these don't really contribute to the prediction, but others do. And here we can really start to do physics, like why is it that the direction of the magnetic field contributes positively during this part of the storm? That's the bright red. And why is it that the density contributes negatively at the same time? We understand more or less what's happening from the physics side, because this is a problem we do understand, but the idea is to now try and apply this to unsolved problems. Right, so the research program that I've been talking about, we got some funding to develop these models. So what you see here is sort of the first version of this toolkit, where if you have any kind of time series problem and you have inputs and you are predicting some kind of output, and you want to know which of these inputs are important at what time, this toolkit is something that we'll hopefully release in the next year or so, and hopefully it will be useful to people beyond our field. And we are already working with them. So the current, my favorite application at this time, we're working with a guy that builds cameras and sensors that go on penguins. So there are these penguins that are fitted with a little camera and an accelerometer, and then trolling through hours and hours of video, you can see every time the penguin catches a krill. It's a little crustacean thing. Now they want to use this for biological models and that kind of thing. I'm not sure what it's used for. The point is that not all the penguins have cameras on. They only have the accelerometer. So now we want to see, using the label data, where someone, typically a student, goes through hours and hours of data and marks every point where the penguin catches something. If we only look at the accelerometer data, so the movement of the penguin, can we guess which of these inputs will tell us that it caught something? And once we have this, we can collect a lot of data, because there's hours and hours of data, not always with video. So in order to analyze this data, in order to get statistics of how much every penguin eats, we need to look at this accelerometer data, and we are currently testing this model on this data. So we are really going beyond the space physics applications. So that's where the other partners in this research comes in. So yeah, this is really exciting stuff, at least for me, and this is what we are currently busy with. So I want to mention some resources. Like I said in the beginning, I'm really not an expert in this stuff. I'm just a user. But there are some really great resources out there. So I wanted to highlight a few of them. So ML Helio is machine learning for heliophysics. Heliophysics means the whole solar system from the sun to the earth. So there's this conference every 2 years. So if anyone here is interested or involved in space physics, especially on, say, on the GIC side, this might be a conference that is of interest. It happens every 2 years. There's a nice website up, and the presentations and the talks from previous conferences are available for download. The textbook we currently use for our students, it's called Dive into Deep Learning. It's a really good online interactive textbook for modern deep learning. So the textbook changes month by month based on new information. It's really good. It has a lot of code examples for different languages. I think you can select 3 or 4 languages: Python, MATLAB, I don't know what the others are. So it renders the code examples according to which language you selected. There's a whole textbook about machine learning techniques for space weather. And then there's a great talk by this guy, Enrico Camporeale. He is the editor of this textbook and also the organizer of the ML Helio conference. So if anyone is interested in this stuff, I suggest look at this talk and see if you can get the textbook. And then something else, I don't know if there are students here that do work in space physics, but as part of this model or of this research, we developed, or we made up this data set of 115 geomagnetic storms between 1996 and 2018. That's 2 solar cycles. We selected out all the big storms. We selected 14 solar wind parameters, 7 geomagnetic parameters from Hermanus and Abisko, and also some global geomagnetic indices, all collected in neatly organized files, and it's available for download here. So this is really something that you can use to test and benchmark models on, if someone is interested, well, either in space physics or just in time series problems. So yeah, that's basically the resources. And so yeah, to conclude, I know the focus here was a lot on solar physics and space weather, and not really a machine learning tutorial. But yeah, to conclude, the space physics and space weather monitoring field are both ripe for analysis by machine learning or deep learning. There are so many papers, conferences, and textbooks out there to consult. So I advise people to dive further into this. And then the really new part of this field is looking specifically at time series analysis, and then specifically at the interpretation of these complex models. These things are really critical, and it's going to become more so in the future. Okay, so any questions? I see there is a few of them. So yeah, that's it from me. How should we handle the questions? Should I just read them?
Yes, we should handle the question now. But before that, I would like to say thank you to you, Dr. Lotz, for sharing your expertise with us. And your talk was truly enlightening. It has inspired us to think critically about the potential of machine learning in solving complex problems in various fields. So actually, we have quite a lot of questions here. Okay, the first question from the floor, from Muhammad Anwar Hussein. He was asking which deep learning model is more suitable for social media contents classification. Please, Dr.
Just for social media, what's the last part?
Okay, I repeat the question. Which deep learning model is more suitable for social media contents classification?
Oh, contents classification. It depends what you mean with social media. Let's assume you're talking about Twitter, so text-based and not images. For that, it would be, you'd have to really look at the what they call NLP, natural language processing models. typically these are what they call recurrent neural networks, or any neural network with a time domain component. So LSTMs, temporal convolutional networks. So LSTM is the one, TCN is the other one. Recurrent neural network, RNNs, is sort of an older way to do things. But all of these, so usually for social media stuff and usually for text-based data, you need a time component because a human sentence or grammar is always time dependent. So what I say in the last part of the sentence really depends on what happened in the first part of the sentence. So it should really be something that has a time component.
All right, thank you. Okay, there's another question from the floor from Mashita binti Abu. The question is, in the initial part of your presentation, you mentioned the process of model tuning. So could you advise on the optimal technique or procedure for carrying out model tuning?
There is no optimal, there is no one answer. It's really, what I can say in terms of techniques is to be firstly very thorough and very careful. I know that sounds like I'm dodging the question, but there are many ways to do what they call hyperparameter searches, and there are many ways to do the training. There is no best way that works in every case. Different models need different ways of doing things. But what I would advise is to, I'm trying to remember the name now. There's what's it called? Weights and biases. I'm going to write it down in the chat. There's a website called Weights and Biases. I'm just typing as I'm talking. So what it does, it allows you to upload your model, and you either train it locally, or you can incorporate something like Google Colab or AWS, so that the model is trained on some other big server. But what this website does, it designs the experiment for you to test your different hyperparameters. So things like learning rates and early stopping, all that kind of, all those tactics that are out there to train a model and to tune the model accurately. This website or methodology tests all these things for you in a very systematic way. So you'll be training hundreds of networks to find the best selection of hyperparameters that works for your case. So sorry about the very long and almost avoiding answer. The answer, there is no real answer, but I would suggest looking at what they do at Weights and Biases. I'm just going to type out the address. Something like that. Okay, so I just typed the address. It's something like wnp.com. I'm just going to search on Google quickly if it's the right. Okay, you can ask the next question, Salam.
Yes, all right. I think I can ask this next question from Nur Afifa Murshida. She was questioning which deep learning model is suitable in determination of risk factor. She was specifically mentioning about in which quantitative data as inputs and outputs.
For risk factor for what?
Risk factors for quantitative data. I'm not sure because this is the only question that was posted by Afifa. If Afifa can mention specifically in the chat box.
It really depends on the application you're looking at. So to determine risk factors, you would really want to look at I think feature attribution. So if I'm still sharing the screen, right? Yeah. So feature attribution. I think for risk analysis, if you want to know which input parameter is the one responsible for the risk, if I'm reading the question correctly, any of these feature attribution methods would work, where you assign an importance to every input feature. I think that would be the way to go there. But it would really, something like this, something like these Shapley values, I think would be useful in that sense. Next question.
All right. I think this would be the last question because it is near to the break time. So the question is, can you give an example of a specific challenge you faced in trying to interpret the results of a deep neural network model in the context of space physics, and how did you go about addressing that challenge?
Okay, so an old one that I can maybe talk about is, I don't have an example on the slides here. So one of the things that we noticed, let's look at this one. One of the things that we know from the physics is that the Z component of the interplanetary magnetic field, now I'm just going to explain what I mean with that. It's the direction, so if you look at my slides now, the direction of the magnetic field in the plasma, and specifically the direction in the north-south sense. That one is very important for geomagnetic activity on the ground. So the reason is, if that magnetic field points southward, downward, it can very easily couple to the Earth's magnetic field, and then the field lines merge and the input of energy is very efficient. So we know this from the physics. What I found in the early versions of these models, ones that I did years ago, is that it saw that the Z component was important, but it almost assigned more importance to the total magnetic field. So that means the total strength of the field in this clump of plasma, nothing to do with the direction, just the total, just the scalar magnitude. And that was a challenge because from the physics, I know it should be the Z component, but this thing is telling me it's the total field. So what I had to remember is that the model does not know anything. It's just basically doing statistics. It only has data to work with. And what I guess what happened, what we think what happened is that the total magnetic field is a very good proxy to say something is going on. So it's not the usual solar wind, which is not very dense, which doesn't have a very strong magnetic field. All that increase in the total field told us really is that there is something coming by the satellite, something dense, something big. And so we had to take a step back and not try to invent new physics to explain why the total magnetic field is important. We had to see it from the model's point of view that only has data to look at and only picked this parameter as a kind of heuristic to say something big is here. So that was kind of a challenge to take a step back and to see things really from the machine's point of view, if that makes sense.
All right, it was a great answer. Right, I think I would like to add another 2 questions because it is a request. The first one is, how do you impute missing data in space physics parameters?
Okay, so I can give either a very simple answer or a long involved answer. So the first thing I usually do, just in practical terms, is I pick a interval. Let's say 10 minutes, because the data I usually work with sample at 1 minute intervals. So I usually pick a value of say 10 minutes, And every small gap in data, so missing points in data that where the gap is smaller than 10 minutes, I just interpolate linear because things don't happen that quickly in the solar wind. The gaps bigger than that, I just leave out. I don't want to try and include things in the model that is coming from my very dumb way of interpolating data. So I usually leave out big data gaps. I only interpolate the very small ones. However, there's a whole, and this is can be a whole project on its own, to design machine learning based models to do the data imputation. Because we've seen so much space physics parameters measured over so many years and so many solar cycles, we've probably seen that kind of thing before, right? So to train a machine learning based model or any statistical model to impute data gaps is an active area of research, and there is research going into this. And I see, is it Lynn that asked that question? I can look for a few papers and send you those if you want to have a look. But otherwise, the short answer is I just interpolate the small gaps less than 10 minutes. Okay, next last question.
All right. Okay, I think the last question here from Morocco. And the participant's name is Pascal Dore, I think. I'm not sure how to pronounce it correctly, but okay, this question is there a unique way to modelize the impact of sun EM on satellites?
Firstly, thank you for the question from the other side of the continent. So you're up in the north, I'm down in the south, but I guess we're all Africans, right? Is there a unique way to modelize, to model the impact of EM on the satellite? I think it depends what you mean with model, but the way I would go about that is to look at the emissions from the sun, probably in the X-ray band. So you're looking at solar flares, not coronal mass ejections. So look at radio emissions from the sun as measured either on the ground or by satellites. So there's a few satellites that measure this out in space. And once you have that X-ray flux, now you can start, and once you have the X-ray flux, and if you know enough about the circuits on the satellite itself, because it depends on how resilient the hardware is on the satellite. If you have information on that, you can start to model just by applying what if so much X-ray flux is applied to a circuit that looks like this. So yeah, I know this is not a very detailed answer, but I would look at two things: the X-ray and other radio fluxes from the sun. Look at like the GOES satellite, GOES, that's measured. And then once you have that, you need to have accurate information on the specific satellite you want to look at, to know what the impact will be on the hardware components of that specific satellite. So that's the way I would go about that.
Right. So we actually have more questions, but it seems that we have limited time. And is it okay with you, Dr. Lotz, if the participants send the questions to your email?
That's no problem. Yes, definitely.
All right, great.
I did list my email address at the end, and I'm sure you guys will share the slides. I will email the slides to Lynn, and then she can share with everyone, if that's okay.
All right. Once again, thank you for your talk, Dr. Lotz, and all participants for your amazing questions. Before we move on to the next agenda, let's take a 5-minute break, and we'll be back and continue with the event.
Thank you.
Thank you so much.
Future 50 is a great way to get started with an IEEE student membership. This is the heart and soul of where IEEE is at its best.
Hi, do you know why we should engage with IEEE Young Professionals early in our career? Well, what is IEEE Young Professionals and how can it help us? IEEE Young Professionals is an international community of enthusiastic, dynamic, and innovative members and volunteers. Any IEEE member can be a young professional, and any member who received their first professional degree within the last 15 years is automatically considered a YP. Now, IEEE Young Professionals is bigger than you may think. It is one community in 10 regions across 183 affinity groups and more than 120,000 members around the world. So, why should we engage with IEEE Young Professionals, you ask? It is a place to connect and network with other professionals, enrich our career and personal lives, and participate in social events and activities. We can participate in many professional networks such as IEEE Collaboratech, IEEE email account via Google Apps, and take part in local meetings and online activities such as conferences and job fairs. We can also access the IEEE Center for Leadership Excellence for on-demand content. This really is an excellent resource to equip us with professional development skills. The benefits go on and on, particularly for young professionals early in our career as well as students. We can enhance our technical skills by accessing eBook Classics, IEEE Member Digital Library, Spectrum and Potential Magazine, IEEE Explore, conferences, and more. Look, the bottom line is this. We can participate in exciting local events and global webinars for topics such as assessing emotional intelligence, fundamentals for leadership and ethics, heroes networking for engineers, survival guide for scientific writing, conflict management, negotiation tactics, and others. For all these great reasons, engaging with IEEE Young Professionals may be one of the best decisions that we can make in our personal lives and professional career development. That is why we should engage with IEEE Young Professionals.
Future 50 is a great way to get started with an IEEE student membership. This is the heart and soul of where IEEE is at its best.
Welcome back to all participants. I hope you did get a good 5 minutes break. So now let's proceed with our next agenda. As for a quick note, kindly put your questions in the Zoom chat box if there is any. All right, we are excited to have Mrs. Mardiati Yunus from Malaysia is our next speaker, and a brief overview of her portfolio to those who may not have had the opportunity to learn about her yet. Mrs. Mardiati Muhammad Yunus received Bachelor of Diagnostic Imaging and Radiotherapy from UKM in 2009 and Master in Medical Imaging from UITM in 2015. She is currently a PhD in Diagnostic Imaging UKM candidate. She has 14 years working experience in healthcare sector as well as in academic institution as a diagnostic radiographer, clinical instructor, academician, researcher, and also involved in management. She is currently working as a lecturer, a program coordinator of medical imaging and lead research and publication unit in Faculty of Health Sciences in UNICEL. Her major interests are conducting research in breast imaging, cardiac imaging, medical imaging interpretation, image processing, and machine learning related to radiomic study. Kindly extend a cordial welcome to Mrs. Mardiati Yunus.
Hello, hi, assalamualaikum, and a very good evening to all of you. Thanks for unmuting me. All right. Okay, first of all, I would like to thank to the committee member IEEE YP, since this is my first time sharing my research findings on the application of automated machine learning in radiomic study. All right. Hi, Nick Zuliani, thanks for coming here. Okay, let me share my screen now. So, can you see my share screen?
Yes, we can see. Thank you.
What about my voice? Is it clear?
Yes, it is very clear.
All right, thank you. So let me prepare this screen first. Okay. So I am just in the technical part here. All right. Okay. First of all, thank you again for inviting me for today's technical sharing session. So my name is Mardiati binti Muhammad Yunus. I'm a PhD in Diagnostic Imaging candidate from National University of Malaysia, UKM, and also currently a lecturer of a medical imaging program in UNICEL, and also leading the Faculty of Health Sciences, Selangor University for the research and publication. Okay. All right. So Alhamdulillah, today I'm given a chance to share about the application of artificial intelligence in medical imaging entitled Automated Machine Learning in Radiomic Study, a Way to Explore. So that is my email. If you have anything to ask or to collaborate after this, so please email me. Okay, before we start with the sharing, let me introduce a little bit more about my background. As you can see here, I was graduated from UKM. Basically, all is related with medical imaging, and none of it is actually related with the programming or computer programming background. Yet, I am very interested to involve in this machine learning application study, especially in radiomics, and actually to help patient, healthcare sector, and also government and to the world actually in diagnosing the images, medical images, in much more quantitatively. As for now, currently the radiologists or the radiologists or cardiologists, for example, in my field, still using their naked eyes actually to interpret the medical images. So I feel blessed to be in this field actually, to involve with this research study. Okay. So this is actually my outline of my presentation, including introduction, radiomics, automated machine learning, research background, the issue, literature review, research workflow, feature extraction, the current trend, research contribution, other medical imaging modalities, and some extra bonus for you all for today, which is hands-on with AutoWeka tools in classifying the features. All right, ladies and gentlemen, that brings to the quote by the father of AI. As we all know, Professor Dr. John McCarthy in 1956, he said the ultimate effort is to make computer program that can solve problems and achieve goals in the world as well as human. So this is like for the introduction of artificial intelligence, machine learning, and deep learning. And this is same as like what our keynote speaker explaining before. So I can skip this slide. So we go straight away to what is automated machine learning tools. So it is actually part of machine learning where it can assist in making prediction by developing and evaluating the machine learning algorithm using search algorithm and application of optimization techniques. Okay, so it is much easier to handle with a very minimal hands-on with programming language and very user-friendly to be used, especially for those who just want to start involved with this machine learning. And it is also can reduce human error because it minimally use human codings able to be used to develop a machine learning model, especially to classify, to predict, okay, and the big and be able to be used as a verification tool actually to verify our model. And it also can even give the best suggestion of the classifier in classifying the features. All right, so that's the advantage of using these automated machine learning tools. So there are some example of it, which is AutoWeka. Maybe some of you have heard before. Okay, AutoKeras, AutoPyTorch, AutoSKLearn, AutoGluon, H2O AutoML, RMiner, tree-based pipeline optimization tools or TPOT, and Transmography AI. So actually in our research, we did use these two tools, which is AutoWeka and TPOT. Okay. So what is radiomics actually? Okay. By definition, radiomics is a field of study in quantifying the information from the medical images or information using data characterization algorithm. So the data is used to help in diagnosing the pathology and has a big potential in managing disease characteristic quantitatively rather than stand on human ability alone. As I mentioned previously, currently radiologists or the cardiologists, for example, still interpreting the medical images using their naked eyes. Okay, so we are more into this AI and machine learning application towards development of the automated software in detection of the disease using medical images. So it also can provide precision diagnostic, prognostic assessment, or predict on therapy response, especially for the cancer detection and also the therapeutic. Okay, so that's the benefits of using this radiomics study. Actually, radiomics study is the application of machine learning and medical imaging. So that's the best part of radiomics actually. Okay. So let's move on to the next slide. So basically, this is the radiomics process. Okay, it starts from the patient itself, referred to our department, which is radiology department, maybe due to any diseases actually. But for my case, for my research, we are dealing with the ischemic heart disease, which is the heart disease related with the coronary blood vessel blockage, or so-called as atherosclerosis. Okay, so when the patient came to our department, the patient will go through the screening process, which is CT scan. Okay, I think most of us know about CT scan. All right, I hope yes. Okay, CT scan is dealing with X-ray and other modalities such as MRI, angiography, ultrasound, maybe quite familiar with you all. Okay, so in my case, I'm using CT scan images of cardiac. Okay, all right, so as we all know, heart disease is the #1 disease that can cause human death in this world, including Malaysia. So that is actually our challenge and also our responsibility to improve on the detection of this disease. Okay, and interesting fact makes me wonder how good the CT machine able to detect this atherosclerosis. Okay, therefore we run this radiomic study to help the doctor to interpret the images quantitatively, and the most important, to eliminate the inter-observer variability in manual reporting, and of course to predict the disease based on the information from the digital images of the CT scan. All right, so the workflow start from the number one, which is data acquisition. When the patient gone through this procedure, the patient will lie down on the table there and the scanning will start. So the image will be processed digitally, and that's what it calls as image pre-processing. Actually, in our research, we did manipulate actually the windowing technique, because as we have read before, the windowing technique may affect on the radiomics features outcome. So, and when we go to the clinical side, we actually collect the data from 2 different centers in Malaysia. Okay, so we found out that 2 different centers having 2 different windowing technique when they did the reporting. So that's make our research much novel there. So we help the radiologists to figure out which one is the best windowing technique, and of course the segmentation technique, whether the manual or the semi-automatic or the automatic segmentation is the best, because they have its own advantage and disadvantages for all these 3 segmentation technique. And next is feature extraction. So when we have already the digital image of the CT scan, we use, in our research, we use LiveX software to extract the radiomics features from these digital images. Okay, and this software able to give us the first order features, okay, the basic features lah, okay, the second order features, and also the shape order features. Okay, so from that radiomics features, so we have to go through this feature selection process, because it gives lots of numbers of features. So in my research, we managed to get about 56,160 features. Okay, and we need then we put these features into our machine learning model, and we use automated machine learning, since automated machine learning may help us to optimize the model much easily and much optimum, and reduce time, and also able to give the best classifier to predict the disease. So that's the best part of this automated machine learning. Okay, so let's figure out this workflow. This is actually the workflow from LiveX software published by NIOSH 2018. All right, so as we can see here, it starts from the number 1 top there, image acquisition, same as on my previous diagram. So any modalities, any images from any medical imaging modalities, such as MRI, CT scan, ultrasound, with having DICOM image of formatting on NIFTY, BMT, JPEG, or PNG. So we managed to load these images into the software. And then next is we have to draw the region of interest, or ROI, on which particular area of we want to figure out or to predict. Maybe this patient have cancer or tumor. So we have done this research also on in comparing on the lung tumor, okay, of X-ray images. Okay, so we need to have an expert actually. It is better to have more than 1 expert to verify our segmentation part. Okay, because we need to verify whether the area of interest is correctly segmentized or not. Okay, all right. And the most important thing also, when we did the segmentation, we need to figure out the inter-class correlation and also the intra-class correlation between both observer, so that we manage to get a good result and verified to proceed to the next stage. All right. And then after that, when this software able to extract out the radiomics features, as I mentioned just now, Okay, we are here at 6.1 here. Okay, let me put it. Okay, so this software able to produce this first order features, the second order features, and the shape order features also be given. Okay, it actually calculated the information from this numerical digital information from the image itself, such as from the histogram, mean, max, or for the second order is GLCM, GLRM, okay? So this is like calculated based on the pixel of the images. And from this output of like LiveX, we will save the information in CSV file. Okay, not at the Excel, but CSV file, formatted file. And we will load this information to our machine learning model, okay? So here we use automated machine learning model to predict the disease. And we are also using supervised machine learning technique lah, other than unsupervised or reinforcement, right? So in our case, we are using supervised machine learning model. So we will teach the model which one is normal, which one is abnormal. We will train the model, and later on we will test the model, and we will see whether the prediction model may give the good accuracy result or not, okay, as compared to the human result. Okay, so for my research background, this is actually was taken from the statistic cause of death in Malaysia from 2021 and 2022. So referring to this study from this Department of Statistics Malaysia, over the past 2 decades, ischemic heart disease remain the leading cause of human death, right? As I mentioned just now, and is about 16% of the total death in 2020. So in line with the data of WHO, World Health Organization stated the #1 death in this world also heart disease, about 16%. And it is followed by pneumonia, okay, cerebrovascular disease, and part of disease in the brain. And heart attack were also more offensive than 68.6% as compared to 31.4% among women now. Okay, all right. So this is, however, according to the most recent statistic in 2022, COVID-19 was the leading cause of human death. Okay, due to COVID-19 lah, right? Okay, due to cardiovascular disease. As you can see, the top 15 country that are having a death due to the heart disease is colored in red color here. Okay, leading by Tajikistan, Azerbaijan, Uzbekistan, and Ukraine, and Oman. And according to the WHO 2020, the number of death is about 16.9 million annually. Okay, so in fact, Malaysia is ranked in the number 61, 61, okay, Malaysia. So it is actually based on the reported from American Heart Association, it shows that the probability ratio to have the heart attack is very bad actually, which is 1 out of 5 people. Okay, so what caused this cardiovascular disease? This is called atherosclerosis lah. Okay, so atherosclerosis occur when there is a blockage of plaque in the blood vessel of the coronary artery, and then it blocks the blood flow to the heart muscle. So because of this condition, patient may get heart attack lah. Okay, so this atherosclerosis is actually divided into 2, which is stable and unstable plaque, right? Which is stated in figure A. And figure B shows the decrease in blood flow caused by severe tissue damage that can lead to the formation of blood clots. And this may cause thrombosis, which is the blockage of the blood vessel. So the one that is much vulnerable is actually the unstable plaque, okay, which is considered as non-calcified plaque or mixed plaque. Okay, but for this stable plaque is actually called as calcified plaque. Okay, but for now, currently in CT scan modality, we only have the automated software to detect the calcified plaque, but not the non-calcified plaque, which is much vulnerable plaque. So that is our contribution actually in our research field. Okay, so do you know what is the machine called? A? Guess? Is it CT scan or MRI? Some of us sometimes get confused whether this is CT scan or MRI, right? Okay, so this is actually a CT scan. Okay, so I was a radiographer actually in a private hospital, and now currently I'm a lecturer. Okay, so the CT machine actually which originally created by the physicist and biomedical engineer named Godfrey Newbold Hounsfield with the support of two radiologists, James Ambrose and Louis Creel in 1971. So this machine used the adaptation of the X-ray first discovered by Wilhelm Röntgen in 1901. So figure B shows the complete scanning form by turning the X-ray tube completely around the patient's body. So when the patient lie down on the table here, so inside this modality having X-ray tube and also a detector. So when the scanning started, so the X-ray tube will turn around the patient's body and producing digital information of data, okay? And it is reconstructed to change from the digital to analog data, and the images can be visualized on the monitor screen and can be printed or burned into a CD. So that is actually where we get the information of the medical images. So what's the issue? Okay, so what's the issue? As I mentioned just now, this is the image of coronary CT scan or CCTA, coronary computed tomography angiography. This is our heart, okay? Heart A, B, and C. So we have three main coronary blood vessel, which is left circumflex artery, right coronary artery, and left anterior descending artery. So in this red circle shows like a very whitish color of plaque. Okay, this is a calcified plaque, which can be seen much better as compared to mixed plaque and also the non-calcified plaque. Okay, all right, so our focus is on these two types of plaque, which is mixed plaque and non-calcified plaque, because this is much vulnerable as compared to this, all right, which can cause death. So this is like a few previous literature from the previous researcher. So I put it into diagram, and I have stated here their limitation and also the suggestion for us to be done. And we also managed to publish 3 papers actually and contribute to this field, especially on the application of AI in medical imaging, focus in detecting the atherosclerosis. All right. So our research workflow, as I mentioned previously, we took medical images or CT scan from 2 different hospitals. We're using 512 slice of CT scan, GE brand, and the second one is Toshiba from Japan. And when we retrieve the medical images, okay, we load it into this LifeX software. So this is the link you can go through and explore. And then we did manage to manipulate the windowing technique, as I mentioned just now, because these 2 hospitals implement 2 different techniques in reporting the images. Okay, and then we did some manipulation on the segmentation, especially in comparing manual segmentation and also the semi-automatic segmentation. And we managed to find the information of inter and intra-class correlation in between different observer and also the same observer. And this LifeX software able to extract for us the first order and the second order, including the shape order features in CSV file. So maybe some of us here have a big data in any field actually. So we actually can load this CSV file data, okay, into this AutoML tools. So what we use is AutoWeka and also the Teapot. AutoWeka is very user-friendly, so-called, because very minimally use coding or programming language. We just click here and there. But for this Teapot, we use Python programming language. Okay. So this is like another image that we have did on the segmentation before and after on the 3 main vessels. And this is the information that be given by the LifeX software, including first order and the second order features, and also the shape of the features here. Yeah. Okay, this is the Auto ML workflow. Maybe some of you are still not familiarized with this Auto ML. So as I mentioned just now, the best part of Auto ML is that they managed to help actually to optimize the model, whereby the feature selection, the feature pre-processing, the feature construction, model selection, and parameter optimization have been automatically optimized by the tools, okay, including AutoWeka lah, okay. Okay, this is just a map, a world map. I just want to show to you our contribution in the publication and research related in this world. Okay, all right. Because we did some review lah, scoping review, and this is our result accordingly to the country. So we managed to represent from Malaysia in doing this kind of research study. So this is our paper actually that you can refer to. This is like Scopus Index proceeding paper, automated classification of atherosclerosis in CCTA images based on the radiomic study using AutoML. And we have 2 more papers that have been published in High Impact Journal. This is related with TPOT model, and this one is related with reproducibility and repeatability of the segmentation part. And we also did a research on detection of coronavirus, COVID-19, during the pandemic session. So we did take the radiograph, X-ray radiograph images from HUKM, okay, in Kuala Lumpur. And we did compare the automated machine learning and also the automate software lah, in auto detection of COVID-19, which is CAT for COVID. And we won the best paper or representation award in ICO10. Okay, so actually this just want to share with you all about our contribution actually, even though it looks like small. Okay, for me it's small because we are more into applied study. We are very minimally use the codings and programming language, but yet still me as personally, even though I have no background in computer programming, still I have to attend a few classes, at least the basic classes of coding, to gain confidence and improve our passion into handling these codes, right? Because as we all know, it may take some hardship into it, especially when they got some error. Okay, so finally I did it. Actually, I have submitted my thesis for my PhD and waiting for my viva. Okay, so this is our research contribution, whereby we are actually a multidisciplinary research, where we combine the medical field related with the disease of atherosclerosis and diagnostic imaging part, which is CT scan just now, and we collaborate together with this machine learning programming, okay, background. So this is what we call as radiomics. All right, so actually this model that we have developed can also be contributed to be deployed and to develop an automated software actually in detection of this disease. And of course this may give impact to the world, to Malaysia, to the government sector, hospital, radiologists, and also to the patient. So like an introduction for the other imaging modalities, because there are so many other medical imaging modalities available with its own big data. Because we are dealing with digital images. We are having, as I mentioned just now, even our research can manage to extract about 56,160 radiomics features. That is only came from about 300 plus something patient. Okay, so we have MRI, magnetic resonance imaging modality. We have X-ray, fluoroscopy, angiography, ultrasonography, and mammography, and lots more, actually nuclear medicine. And these are also available in most of the hospitals, government and the private sector, and also clinic for the X-ray, all right? And we involve in detecting so many kind of diseases, okay? So it is suggested actually for the next researcher maybe who are interested to involve more in this radiomic study to explore other medical images technique. And this is in helping the nation to develop a machine learning model. Okay. Oh, we have bonus here. Okay, so this is the technical part. Do you like bonus? Okay, a present for you today. Okay, so it's actually an AutoWeka hands-on, all right? So what is AutoWeka? All right, AutoWeka is Waikato Environment for Knowledge Analysis, WEKA, developed at University of Waikato, New Zealand. And it is a free software licensed under General Public License. It is developed using Bayesian optimization techniques, okay? And the data set loaded into the AutoWeka software is without coding, and it is easy to use, right? So maybe some of you have develop your own model, and maybe this AutoWeka can be used to verify whether your model is good or not, or giving the same result or not. Okay, so AutoWeka has been used in this study to select and suggest the best classifier. So let's start. Okay, what we need to have actually. So actually this is my real data in CSV file. I just want to show you some example. Whereby we have put here the patient ID, and this is the patient vessel, because as I mentioned just now, one patient have 3 main vessel of the blood vessel. So that's why we number it as 1, 2, and 3. And this is all the radiomic speeches which produced by this LifeX software. And at the last column here, actually, you need to put the result or the diagnosis of this patient. So this need the involvement of the expert from the hospital. Actually, we call it as radiologists, or in National Cardiac Institute in Malaysia, the cardiologist able to diagnose the images. So we involve the cardiologist also in this research. Okay, so we have to put another extra column at the end back here, which is the diagnosis, because this is part of supervised machine learning. We have to supervise the model and train it, and later we test the model and see the result of the accuracy. Okay, so maybe some of you would like to explore more. You can download the AutoWeka apps, okay, or tools. This is the link, right? You can start to Google the link here. Okay, and then you can open the Weka software. When you have download this AutoWeka software, okay, you have to click at the tools button at the top here and click package manager, okay, to upload the AutoWeka package, because some of my friends actually unable to use this Weka because haven't downloaded this AutoWeka package. All right, so that's the first step. Actually same like using Python language also, right? So create an AutoWeka search and click install. Okay, so you can just click the button here. All right, click AutoWeka and install. Okay, first of all, of course, you have to type the name here lah. Okay, all right. Then click the Explorer button and then the pre-process button. So we have Explore button here. You can click here, and you can click the pre-process button over there, and you can start to click the Open File button. And this is where you have to choose the CSV format file, and you can choose your file, the one that I showed in the previous slide, the first slide just now. Okay, so that this software able to retrieve your file. Okay, so then we click the AutoWeka here at the top after you have installed it, and click the button Start. Wait for a few minutes for the training process to be carried out. Okay, this is actually in Malay. I will translate for you. AutoWeka will give the best suggested classifier actually, okay, for you to train the model, the input data just now. Okay, then you click classify and type 80% because we use 80-20 percentage of split data, okay, for the training and testing. So then select the choose button here. Okay, choose button here. And then select the choose button classification algorithm as suggested. Because when you train the data just now, actually, the auto waker will give a suggestion which is the best classifier for your input data. So that's the best thing about auto ML. They will help you to optimize the model. All right. Okay, and then you put it here, the random forest now, because they suggest to use random forest, and you edit here 80% and you click start button. Okay, very easy. Okay, and then to get more detailed precision value and confusion matrix schedule, click pre-process. So this is for the visualization part when you want to have the graph, okay, of your input data. So you can click follow this guideline. Okay, click generate and then classify and start again. Okay, then we start here to to test the model. Actually, previously is training, so this one is the testing the model. Then later they will give the result. Okay, the precision, including the precision whether your model is good enough or not. The best result is closer to 1. Okay, so if less than 0.5, it's not so good now, actually. So to get the ROC curve, receiving under the curve, so click the right mouse button in the empty space section in the result list here. You just right click and then click visualize threshold curve. Okay, you just click this one, visualize threshold curve. Then later, they will give this ROC curve for you. And then finally, you manage to get your area under the ROC curve lah. Okay, whether your model is accurate enough or not. So this can be used as your visualization part for your result. Okay, I need to see whether your model is accurate or not. So actually, that's all from me. Thank you.
All right, thank you very much, Mrs. Margati Yunus. It was an interesting presentation and we appreciate the time you took to speak with us today. And your presentation was very clear and I'm sure the other participants also learned a lot from it. So we have actually 3 questions and the first one is from the participant. His name is Asif and the question is, which field mostly use auto machine learning?
Okay, actually, I'm not unmuting myself. Okay, so which field? Actually, we can apply this automated machine learning for any field actually, as long as you have the data, the big data. So that's the interesting part. As long as we have the features, like we call it as features, and we have the samples. And for my part, I have the diagnosis, the result of the classification or prediction. Then you can start applying this automated machine learning. And they have lots more other than AutoWaker. AutoWaker is for me, the most simplest one because we just need to click the button. And yet still we can able to manipulate the information whatever we want. They got so many things also we can manipulate there. Okay, so any field actually. Yeah, that's my answer.
All right. Okay, thank you so much. All right. We have another question from the participant. Her name is Zuliani. Okay, the question is, what challenges did you encounter when developing machine learning application for real world devices such as CT scanners?
Okay, so my biggest challenges is, number 1, we have done this research during COVID-19 pandemic session. So as you all know, we really need to get the ethics approval from the hospitals. And I'm involved with 2 different centers, cardiac center in Kuala Lumpur. And it's quite far for me actually to go there. And during the pandemic, the rules is very strict. We need to have vaccine first, then only we can go there. But actually all the challenges can be managed. actually, when if we have a very good collaboration with the expert in the hospital, such as the doctors and also the radiographer. So that's how I manage the challenge. And number two, of course, as you know, I myself have no coding or programming, computer programming background. So how I manage this is that because I know this is the current trend in my field, and I believe for all field, for all of us actually, right? So we are towards the AI or IR 4.0, again. So we are towards more into artificial intelligence. So I don't want to set back, you know. So I have to learn. I have to learn to face all these challenges. I've been through about 8 programming classes related from basic to deployment of the model, to deploy the model. So I've learned all that, and that is very that's the best thing actually about the challenges. And actually, other than that, of course, related to my study field in CT scan. So CT scan, we need to consider the image itself. Okay, the image. We need to consider the image quality. For example, because I'm involving 2 different brand of CT scan. So we know the technique is different. We know the radiologist involved also different. The radiographer involved also different. The patient itself also different, because I'm involving scanning of the heart, where the heart is moving, right? When scanning started, the heart is moving. So it might get the blurring artifact. Okay, so I need to control the you know, the exclusion criteria and also the inclusion criteria in getting these images retrospectively. And I'm also need to exclude the patient who have a very high body mass index and not the good quality one with artifacts. So I need to control on that. So that's my challenge, and that needs my expertise in medical imaging to go through all this. Do you need more? Actually, they got lots of challenges, but I can alhamdulillah, I managed to handle it.
I think that's a great question for now. Okay, another question from, I think it's Mr. Shut up. All right, the question is, does Autovika also helps with the data augmentation if the data set is insufficient to train and test? Or what other techniques you recommend to use for data augmentation? All right.
Okay, the first part is I need to clarify back the definition of data augmentation. Okay. So as I know, the one that you said that in terms of the augmentation itself, you're improving the size or the amount of it, but I need to focus on the question of you regarding the sample size. Okay, so actually that's the tricky part. Maybe some of us query about whether this automated machining can handle a small size of sample or not, or they really need a big size of sample. So actually, I'm using the TPOT tools, 3-base pipeline optimization tools using Python language. So we have tried actually 3 times using very small sample size, medium, so-called medium, and also the one that we calculated using sample size calculation now. Okay, so that gave different result. Okay, that gave different result in accuracy of the prediction. So of course, the very small one, actually we try less than 20 patient actually. Very small, less than 20 patients, so very small. So the accuracy is very bad lah actually. Okay, about 50% only can able to predict, because they are unable to learn more, because we are applying the supervised machine learning model, right? So we need to train the model, train by giving lots of inputs to them. Okay, so called. Okay, so then the result is not good lah. Then when we improve into bigger sample size, the accuracy also improving. So that shows that we really need to consider about the sample size, but not as much as deep learning. Okay, if I'm not mistaken lah, deep learning need much more samples as the input data. I hope I'm answering the question.
All right, I think that's a great answer. Okay, we have lots of questions. All right, the next one is from Annie Hayati Noruzman, great name. Okay, her question is, how do you determine future selection? Is it that you choose in AutoWika or from Python?
Actually, for this automated machine learning, as I mentioned to you, it has its own black box, okay, where we are able to manipulate it, especially on feature engineering or feature selection. It has been optimized by the tools, so we just follow whatever the model suggested to us, and I'm just only figure out on my part, which is windowing technique, because that's my gap actually in my research field. So I'm focusing on the manipulation of the segmentation itself, technique, segmentation manual and semi-automated segmentation, and also the windowing technique of the CT scan images. Other than that, I'm just using these tools to help me to predict the input data. Yeah.
All right, thank you. Okay, we have another one question again from Pascal Dore, is it? His name? Okay, he's from Morocco. And the question is, what is the advantage of using auto machine learning?
Okay, as I mentioned just now, they have a lots of advantage. Number one, as compared to the conventional machine learning, such as, SVM, even random forest or what, manual, I mean like the manual one. So it use very minimal human error. Human error. It will minimize the human error when we less using the codes. I mean, like, manipulating the codes by ourselves, something like that. So, and of course, number one. Number two is it helps us to optimize the model already. Okay, and it is very good for us, as I mentioned, to those who having no background of computer programming, background, then it is very good for us to apply this as for the application on our data. And then very fast, as I can say, because I know handling using Teapot, which is using Python programming language, and also the AutoWika. AutoWika is much faster to train and to test the model as compared to Teapot using Python language. Okay, so that's the comparison. The length of time is very much different actually. Maybe like half day or even 3/4 day for Teapot, and for the AutoWika is like a few hours only, like that. But it actually depends on your computer speed also, right?
All right. Okay, so another question from Salami Olukbunga. Is it okay? I'm not sure whether you have answered this question. I think you have, but just mentioning again this question to you. Can auto machine learning be used for predictive modeling?
Yes, of course.
Right.
Of course.
All
Yeah.
right. All right. Okay. So the next question is from Nur Ashikin Ismail. Her question is, do we need to convert DICOM images to Nifty format? Nifty, yes.
Yeah. Actually, okay, I have handled this issue also. When at the first start, I tried to load JPEG and JPG JPEG file into this LiveX software. But the JPEG actually is the reconstruction images from our real data, okay, from our database. But it cannot read it. The LiveX software cannot read that. So when I gone through the manual again, they said that we have to just we can try to upload the DICOM and Nifty, right? The Nifty one. Okay, so actually we can try to convert it. You can use MATLAB, okay, or any other tools to convert it. But for my case, I use the real hospital from my hospital data. So the real raw data, which having much more information within the original data. So that's how I did my research. But not compulsory to change or convert to Nifty format. You can use DICOM format actually straight away.
Let's see, that's amazing. All right, so we have another question from Muhammad Sekruni. The question is, have you tried analyzing signals of the heart instead of analyzing images of the heart?
Okay, so a very good question. Actually, to detect the abnormality of the heart, it involves lots of other modality to diagnose this disease, a heart disease. One of it is signals or ECG, right? So we, in our center, we didn't do any research related to these signals, but we did collaborate with the expert from Singapore. If you can go through his name, Rajendra Acharya. Okay, this is he is actually our expert in field in Singapore, giving lots of advice to us, and he did this research on signal processing to detect heart disease. Okay, so you can go through the papers. Maybe I can type the name here. Something like that. You try, yeah? He is from Singapore, and he did research at Universiti Malaya, Kuala Lumpur. They collaborate research with Universiti Malaya, Kuala Lumpur.
Right. So I'm sure you have answered the question to Muhammad Fikroni. Right, we have another one from College of Fisheries, Tripura. His name is Dr. Prasenjit Pal. Okay, the question is Auto-Wika and Wika GUI, are they the same thing or are they actually different?
All right. Okay. I'm sorry if I give the answer wrong, but if I'm not mistaken, Auto-Wika, as I mentioned or explaining to all of you just now, is it's like a software or tools, automated tools where you can just click the button, something like that. So for this Auto-Wika GUI, I'm not involved on this one yet. Maybe same, maybe different. Let's explore after this.
All right, okay. From Mashita binti Abu, another participant of ours. So her question is how to calculate the sample size for medical imaging.
Oh, okay, very good question. Okay. Actually, I'm using the basic formula actually, but I forgot the name. Wait, I'm actually using the standard formula for the sample size calculation. There is not any difference between sample size calculation for medical imaging or any other field. Yeah, you can use the standard one, but maybe I can have a look on that. Maybe I can share for you 1 second.
I'm sure.
They got lots of tools, right, to calculate the sample size, but you can use the standard one actually.
Right. I think you have answered the question. I think Ms. Marjati will I think she will try to answer the question through email if that's possible.
Yeah, can, of course.
All right. Okay. Another question. So interesting. Your presentation was so interesting. So another one is from Ekin Oyelakin. Right. Interesting name. The question is, are there funding available for this kind of research?
Of course, there got lots of funding available, because some more this is like a multidisciplinary research study where we involve healthcare sector, IT, programming, and of course in helping people out there. So they have lots of grant available, focusing on science and applied science, something like that. Okay, science and technology. So you can apply for the local and international grant. For local, we have FRGS for the fundamental, PRGS, and international we have lots more, right? TORI, Grant TORI, and science and technology and innovation grant. They got lots of the grant, and actually they are very interested to accept this research to grant you. Okay.
That's interesting. Okay, another question from Daha Shihu. Wow, today we have lots of participants from around the world, isn't it? All right. Okay, the question is, what is the difference between the modeling using artificial intelligence and the one used to modify the developed equation?
What is the difference between the modeling using AI and the one used to modify the developed equation?
Yeah.
Okay. I think you have to for me is almost the same, but then what I'm focusing here is the automated one. Maybe you can go through the first slide actually, as for introduction, the by definition, what is artificial intelligence, what is machine learning, and what is deep learning, and to do one used to modify the developed equation. Maybe you came from the mathematics background, so yeah. I'm not quite sure to answer this question correctly, but then yeah.
Okay, it's okay. I think we are now at 5:32 p.m. So other questions maybe you can email to Mrs. Mardiati. And Mrs. Mardiati, actually your presentation generated a lot of interest among the attendees. So many of them have asked if they could receive a copy of the slides that you presented today.
Oh, for sure. Okay, for sure. Actually, it's
Right.
part of my PhD thesis, but it's okay. That's for you.
All right. And we are also happy to inform you that Dr. Stephen has agreed to share the presentation slides, and our team will be sending them by email to all the attendees. Right. Thank you so much, Mrs. Mardiati, for your concise and understandable answer. Our explanation was superb, insightful, and I believe it will aid the audience in getting a better understanding of the topic. Right, ladies and gentlemen, we will resume our summit session now. And before we proceed, please don't hesitate to ask any questions again by typing them in the Zoom chat box. And a quick reminder, we'd like to take another group photo with all the speakers and attendees after this session. So do get yourself prepared to turn on your cameras and pause for the screenshot. And please kindly put up the photo background for a much better photo experience. All right, so our upcoming speaker is Dr. Felipe Benavides, a talented Colombian scientist who graduated from Universidad de Narino in Colombia and earned his PhD in ecology from Universidad Austral de Chile. He is currently a postdoctoral researcher and adjunct lecturer at the Universidad Nacional de Colombia. He also works as an external researcher for the Hydrobiological Resources Research Group at the Universidad Nacional de Colombia in Palmira, as well as the Agroforestry and Natural Resources Arena Group at the Universidad de Narino. His research focuses on topics related to biostatistics and environmental data science. And Dr. Benavides is also an enthusiastic science communicator who regularly gives conferences, courses, and workshops on environmental data science worldwide every month. And his current main interests involve the application and development of new machine learning tools in R, Python to address both old and new questions in the field of environmental sciences. Please give a warm welcome to Dr. Felipe Benavides.
Hi everyone. Can you hear me?
Yes, it's very clear from here, Dr. Felipe.
Okay, thank you very much for your invitation. I'm happy to be here to share some reflections on environmental science, machine learning for you. Okay, so I'm curious, can you still hear me?
Yes, it's very clear from here.
Okay. Just let me place my camera here. And I'm going to share my screen now.
Right.
Okay, so can you see my screen and can you see my slides, my PowerPoint slides?
I think we are seeing the Zoom background here. It's not your slide yet.
Okay, I never use Zoom. This is my very first time, so
I see.
Please hold on while I
It's
find
okay. Right.
the
It's
right.
okay. Take your time.
I have 3 screens connected to my computer, and I just need to find out which one is right to share the PowerPoint slides. Hold on a second. I think this is the right one. Is it?
I think, all right. Okay, now we can see your slides.
Okay, there you go,
All
right?
great. Yes, machine learning. All right, great.
Okay, so it's 4 in the morning here. Still, I love to be here to share these ideas with you. I see there's people connected from many countries, so please feel free to send any question during or after the presentation. I will keep the chat box open here. I would like to see where you guys are connected from, which countries, which universities, what's your background, what's your main research. I would like to read it while I make my presentation. Thank you very much for the invitation to Young Professionals Malaysia. I really appreciate also the other two speaks from which I learned a lot indeed. And well, now I'm heading to present these ideas I entitled Machine Learning for Environmental Problems and Sustainable Development. Well, this talk is about mainly, I'm not going into technical issues, not going into technical details of machine learning, but this is more like a philosophical reflection on the purposes of machine learning for environmental problems, the advancements we have made so far for sustainable development, the kind of questions we are trying to answer using machine learning techniques, and how it implies a paradigm shift, actually a scientific revolution. For this applies to every single science, but of course, since my background is environmental problems, I'm going to outline a little bit how this paradigm shift, how this scientific revolution is taking on environmental problems. So, okay, I see there's people from Salam, student in UNIMI University in Malaysia. Okay, I'm reading don't forget I'm reading the chats you sent here. So my background is environmental sciences. I am a biologist, PhD in ecology, and my current research focuses on applying machine learning methods and also developing new machine learning methods to answer research questions for fishery sustainability, right, in the Pacific Ocean. That's my main area of research. But I also participate and collaborate with other research groups. For example, developing machine learning tools to predict plant disease, to predict animal disease, to predict deforestation, or to measure deforestation, and so on, different kind of questions within the environmental sciences. So machine learning is, of course, empowering the scientific community so much that I usually relate it or compare it with giving it superpowers for environmental sciences, because machine learning is giving us a power to prediction, right, that we never had in the history of the science before. So now we can predict, and this is the main purpose of machine learning, the prediction, as opposed to explanation, which was the main focus of science, let's say, during the last century. But now machine learning is giving us superpowers to predict environmental processes in space and time. So we can actually, how do you say it in English? I'm sorry, English is not my native. So we can foresee what's going to happen, right, in space or in time, in order to make the best decisions for the environment. The best decisions of how, for example, how to invest our budgets, which are very limited, to protect the environment or to sustainably use the environment. You know, most of you probably know what's the main environmental issues, environmental problems that the Earth is facing right now. And as a scientific community, we environmental sciences, of course, are taking a lot of benefit from foreseeing what's going to happen in order to make the best decision making. Okay, so let me see, what is data science? Well, machine learning, I usually deliver this slide because machine learning is within data science, is one of the tools of data science, as well as statistics or exploratory data analytics, as well as mathematics, as well as data mining. So machine learning here, you can see, is just another tool of this big toolbox that science in general has to answer or to make better answers to research questions. So in data science is then a multidisciplinary study of reality through data. We can also define it as a big toolbox to study our world through data. So, and then what is environmental machine learning? We saw that this is part of the data science, part of that big toolbox. So what is machine learning? And no, it's a small part of data science that tries to answer research questions based on predicting stuff, predicting phenomena on using data, using from small data to big data. It is not always related to big data. That is a common mistake. Let's take a look at this meme. Yeah. You know what? In environmental science, in the university courses, we usually take biostatistics first, and never machine learning. But machine learning usually comes at the postgraduate studies, and sometimes we don't even take machine learning courses on postgraduate studies. So it's a very difficult journey from biostatistics to machine learning. For example, when we are trying to think of our thesis or PhD dissertation, and we find out that there's a new toolbox called machine learning, but we only learn statistics. It's a really tough journey to learn these new tools. So this is a meme. This is a very funny meme that describes the misconceptions about machine learning. So machine learning is not sophisticated statistics, even though there are some, of course, common procedures or common concepts. But going from biostatistics to machine learning, it implies a shift in the philosophy of how we make research questions and how we approach research questions. Do you remember Scooby-Doo, the Scooby-Doo cartoon? Right?
Yes, of course.
Right. So also like I was telling you before, going from statistics to machine learning is a tough journey for environmental scientists that we are not learning. I mean, most of the undergrad programs in environmental science are not teaching machine learning as part of their curricula. So we need to discover it, and most of us learn it by ourselves later. And one common misconception is that, okay, machine learning it is just more sophisticated statistics. So though those two areas might have stuff in common, of course, philosophically they are different, and the kind of questions they answer are also different, and the purpose is also different. So statistics are mainly focused on summarizing data and giving explanations, making explanations of how one variable causes effects on other variable, while machine learning is focused on predicting, making good predictions. So how this machine learning implies an update in the philosophy of how research questions are formulated. Of course, this applied not only to environmental sciences, but all sciences. So we go from a research based on theory, right, to research based on data. I mean, sometimes the background theory used to answer a question that is looking for predictions can even get rid of theoretical assumptions and just go straight to the predictions. Second thing is that we go from questions to data, and we move from data to questions. So we invert the process of making questions in the scientific method, right? So in classical research, let's say classical, right? We make a research question, environmental research question. We go to the field, we take the data, and then use that data to answer the question. But within machine learning, we need to learn how to make questions from the data. So there's a huge corpus of data available right in the internet, and we can make questions by looking at the data. And this is how many of the environmental research advancements are making today. And the third one is we are looking for explanations, right? This is the let's say the classical approach within environmental research. We're looking for explanations. For example, we want to know how temperature affects the distribution of a species, or how how relative humidity causes an increase in the rate or the rate of a disease, incidence of a disease, while in machine learning we are looking to predict that disease. So looking for explanations, we are going from looking for explanations to looking for predictions. For environmental scientists, acknowledging this, right, and making the philosophy shift is not easy, at least for my generation that learned first biostatistics, and then we have to learn machine learning on our own. This is a difficult journey. But once we do it, once we reach it, it is a very enriching and very powerful source of answers in environmental research. So then what's really environmental machine learning? It's actually machine learning algorithms and their associated procedures, but applied for environmental questions using environmental data. And what are the environmental sciences? So speaking sensu lato here, we can include biology, ecology, forestry, geology, geography, environmental engineering, agronomy, hydrology, oceanography, climatology, epidemiology, demographics, etc., among others. Basically, all the environmental sciences have been influenced by machine learning. Currently, there is no one escaping from this revolution. So, like I was telling you before, this implies something really important. This is a huge thing. This is a paradigm shift, right? So paradigm shift that we go from theory-based science to database science. And here in 2023, we are in a transition area between both paradigms. So in theory-based science, which is the approach that dominated the science for the last 300 years, basically. So you are within a theory, you make the questions within the limits, within the boundaries imposed by that theory, and you collect the data also within the boundaries of that theory, right? And then you go to the field, you take the data and you try to answer your questions with the data that you collected, but also you answer your question within the boundaries of that theory. This is theory-based science. Within the database science, you can get rid of many theoretical assumptions. And since now we have a huge corpus of data, right? You can just take a look at the data, figure out what kind of questions you can formulate with that data, formulate your question and use that data to answer your question. Now, both are important. I'm not saying that we are 100% getting rid of theories, but today, I mean, the way science is advancing and really getting enriched is by the intersection of these two paradigm approaches, right? So environmental scientists are it is absolutely necessary for environmental scientists to learn these new tools and to collaborate with other people, other research groups, other labs in the world in order to plug in machine learning algorithms to empower the research answers that we are making to protect the environment. So another concept right here that I'm sure that you have heard is big data. So one of the reasons machine learning for environmental applications are evolving so fast is because we have the data. We have enough data to train machine learning algorithms to make good predictions. So it is said that today 20 terabytes of environmental data are being produced every day. So try to figure out 20 terabytes every day. This is huge, right? And it is mainly being produced, of course, by big corporations related to or somehow linked to environmental endeavors. So Google, NASA, the NOAA, Environmental Protection Agency in the United States, Copernicus in Europe, the IPCC also this is globally, the NIPCC. In each country where you live, you can figure out a big company, right, producing environmental data every day. And what kind of data is that? And here comes another concept called the 5Vs of big data. So it's data of high volume, high variety. So different kind of variables, different kind of traits, right? High speed to high velocity to share and to produce, to pre-process and to analyze the data, the veracity and the value for environmental purposes. So all these 5B of big data are pushing database science for the environmental science. So new machine learning algorithms allow for higher power of prediction in all of these sciences that we saw before, right? All of these are today how do you say, they are, oh, I forgot the word in English, but they are all connected or linked to the paradigm of data, and they are using machine learning algorithms to answer old and new research questions. One of the interesting things about machine learning is that they are allowing to make new research questions, to figure out new research questions that were impossible with the theory-based science approach. Let's check it out. See, if we go to the web of science, right, in clarivate.com, and we make a search with two keywords, environment plus machine learning, from 1980 to 2022, actually, the number of publications has increased exponentially since year 2000. So see, for the last full year, 2022, close to 10,000 publications were done in the intersection of environmental sciences and machine learning. So this is huge. This is really, we are facing a revolution in how to produce research questions and research answers to protect the environment using machine learning. Some recommended readings, if you are interested in, let's say, have a wider scope of how machine learning is making a revolution within environmental science, you can read the 4 Paradigm book, Data Intensive Scientific Discovery. This is a book that this is really enriching because it has 5 chapters. One chapter is for environmental science, but the other chapters are for, let's say, medical science, health science, agriculture, social science. And this book really gives a wide scope of how these 4 paradigms taking place in each of these research areas you work in. Also, this big data explaining its uses to environmental sciences, right? And in eco-informatics, supporting ecology as data-intensive science. This is a paper that was published in 2012 in Trends in Ecology and Evolution, and also gives a very interesting scope of how this revolution is taking place and changing many things of how we do research within the environmental science. So what do we need? What do we need in order to make environmental science with machine learning, or applying machine learning techniques to answer our questions? So it implies the classical steps from collection, cleaning, exploratory data analysis, model building, model deployment, and we need to learn some programming languages. So for example, SQL, Python, and RStudio, RList, or at least one of these: RStudio, Python, or Python and SQL. Very important to learn how to manage relational databases. So this is something that we don't learn in the university, let's say in the undergrad studies in biology or ecology or environmental engineering or conservation biology or climatology. This is something that we are not learning in the let's say official curricula, right? Some universities, of course, top 5 universities are starting to incorporate machine learning courses. So of course, Harvard, the MIT, Massachusetts Institute of Technology, Oxford, University of California in Santa Barbara, they are starting to incorporate machine learning courses for environmental careers, environmental undergrad studies. And this is something we really need to move on in order to empower the new students, the future environmental scientists, to face this revolution, right? And let's see what kind of environmental questions can we solve using machine learning. So if you have any question, right? If you have any question on the, you can write in the chat. I have the chat box open here. While I take a break, because this is probably, I have never spoken in English for so long, and I hope you are understanding my English. And I promise
so far it's okay with us. Your English is understandable.
Okay. Okay. So is anyone here related to environmental research or environmental careers?
Anyone from the participant?
Yeah, we're going to make an exercise. Please write, or if you are related to environmental science or not, please write an environmental question, an environmental research question that you think we can solve with machine learning. And meanwhile, I'm going to show what kind of research questions are today being answered with machine learning techniques. And I'm going to show you that whatever your question is, it is able to be solved with using machine learning, and we are going to Scholar Google to show you that someone else is doing it, or has done it already. This is amazing, because if you go to Scholar Google and you type any occurrence, any kind of keywords relating any topic within the environmental science and machine learning, you will find something. Okay, so what kind of environmental questions can we solve with machine learning algorithms? So a very classic questions is, what is the probable distribution of a species in the future. So, you know, species, biological species occupy a geographical range because the species is adapted to a combination of environmental, let's say, conditions, right, that make that species suit to a particular geographical range. So what's going to happen? What's going to happen in the future? Let's say with changing climates or changing scenarios of management, environmental management. What's going to happen with that distribution? Is it going to grow? Is it going to expand, or is it going to collapse? Right. So machine learning is helping us to understand what's going to happen by using a combination of, let's say, satellite-derived information, right? And future scenarios, for example, of climate change scenarios, and we can apply machine learning in order to see what's going to happen in 20 years or in 30 years or 40 years. We can predict if the species is going to expand. Is it going southwards? Is it going northwards? Is it going westwards, etc.? We can see all the possibilities involved with that geographical distribution. And you know, of course, many species are important for agriculture, for feeding. Other species are invasive species. So that helps us to foresee the best decisions for managing that species. Another research question have collaborated with this one with researchers from Universiti Teknologi MARA is can we predict the onset of plant diseases from early plant stages and using measured traits? So you know, of course, that plant disease is a very serious issue because it can ruin crop yield entirely. Some plant diseases can just, let's say, prevent crops to yield correctly, right? And that implies problems for the food security. So if we are able to predict the onset of a disease during the early stage of the plant with easily measurable traits, so we can classify plants, right, from the early stages of the crop process in order to isolate them from the rest of the plants. That saves a lot of money, that saves a lot of time, and that prevents the crop yield to being ruined. So using, for example, a lot of pictures from leaflets with the disease and without the disease, we can train deep neural networks, actually convolutional neural networks, in order to predict if that plant is going to have the disease later or not. That's a very interesting question that we are trying to solve. We are building an application, a cell phone, mobile phone, smartphone application for farmers in order to, they just go take the picture, right? And based on that trained neural network, he gets the answer of how probable is for that specific plant for getting the disease or not. Another question, what will be the total crop yield next year? For example, if you have a plantation of potatoes and there is a lot of uncertainty about next year conditions, soil conditions, or climate meteorological conditions, etc. So you can train, for example, extreme boosting gradient with different traits of the potato crops in order to predict what will be the crop next year, based, of course, on time series. You need time series of previous year in order to predict, to forecast the next year crop yield. Which risks, another question, which risks are more important for a protected area to work on the budget? So, as you might know, the budgets for different nations, one of the poorest budgets is for environmental protection. So people working on, let's say, for example, protected areas, right? Areas designed for conservation always work with very limited small budgets. So they try to make the best, let's say, to prioritize actions or to prioritize species or to prioritize ecological functions in order to get the best approach to the objectives they have in their protected plans, in their conservation plans. So they are using machine learning algorithms, for example, to predict deforestation on the surrounding areas, right? To predict deforestation patterns in order to stick to their budget and do not invest more than they have, risking not to reach their objectives. Another question: automated classification of species, ecosystem-based species and ecosystem. Sorry, there's a typo error here. Automated classification of species and ecosystems based on satellite and aerial images. So some machine learning techniques are being developed and applied in order, let's say we have this picture that we take with a drone, and we have to, let's say, find which species are here. Okay? In the classical approach, we have to go to the field. We have to, let's say, set some plots, some sampling plots, collect the species, then go to the laboratory and identify the species using classical taxonomy or using genomics or any other approach to identify which species those are, but which takes a lot of money and takes a lot of time. But using some machine learning algorithms, we are starting to train those algorithms to recognize which species are here without needing to go into the field. This saves time and this saves money, and of course the let's say the spatial scale, the scale we can work is huge compared to the classical scale, much more smaller scales that we were allowed to with the classical approach of going to the field. And of course, this is this automation is contributing with huge advancements to environmental sciences. Other publications that you should read if you are interested: a deep learning neural networks approach for predicting desorption of ionizable and polar organic pollutants to a wide range of carbonaceous materials. Forecasting Amazon rainforest deforestation using a hybrid machine learning model. They are predicting where deforestation is going to take place, most probably. One from my research group: projecting future changes in distribution of small-scale pelagic fisheries of the Southern Columbia Pacific Ocean, right? From my boss, Professor John Selberach, and collaborators. And one that we published this year, this is a new machine learning algorithm that allows you to automatically find the best method for making imputations for missing data in time series data structures. So just some of the examples. So to this point, we can easily see that machine learning is a big toolbox, right? That allows us, environmental scientists, to answer old and new research questions with much more accuracy. And this is actually pushing a new way, a new paradigm to make science, to answer research questions, and to more appropriately and more effectively protect the environment. So with the statistics, you have good tools, of course, right? But with machine learning, you have good and much more tools. And, one important reflection that I usually make with my students or in different conferences is that, okay, not everything is perfect, and we need to be careful with the data paradigm because some considerations have to be made about what is big data, who owns the data, because big data is big money, and not all of us are capable of producing this huge amount of data. So if we want to work with machine learning and big data, we need to go to the sources, to the main sources who are today producing the environmental data, right? Or let's say data in any other science, not only environmental science. This applies to any area of study. So those ones having the data are today those ones having the power. So some of the implications of relying on these big data providers is that probably the spectrum of research questions can be constrained, right? Because we are not free anymore, let's say, to go to the field and collect the data the way we want to answer a specific research question, and we design a study to collect the data. We need to rely on their data. And the way we make questions, I mean, the day data is produced determines in many aspects the kind of research questions we make. So we need to be philosophically careful with this and other issues related with who has the data, has the power. You can read a reflection article that I published last year in October or November last year, the pros and cons of big data and artificial intelligence for research, right? How, of course, it gives us a lot of empowering new tools, new data, more accuracy to make predictions, but also we are continuously relying more and more on who produces the data. And this might have political, geopolitical, right, and philosophical issues that we need to be careful. We need to take, at least be aware of, right, and make some considerations. You can use this link if you are interested in this article. The article is published in Spanish, but you can easily translate it using Google Google Translator. Okay, so I'm going to show you something based on the before I want to thank you all so much for being here, for participating, for paying attention. Thank you so much. Terima kasih semua. Saya ingin menjawab soalan Anda. But before that, I'm going to show you something. We are going to Scholar Google. Right? I'm going to just copy and paste the questions that you wrote on the chat. For example, Shadab says, do you recommend, oh, excuse me, this is another question. Okay, so someone is asking, Chong SL is asking, I am dealing with lactic acid bacteria to enhance the production of lactic acid. So let's write lactic acid plus lactic bacteria plus machine learning. And there you go. Potential of probiotic lactic acid bacteria with antimicrobial.
Dr. Felipe, I think we cannot see your screen. I think you should share your screen. Yeah.
Okay, I need to
the one that
change.
you are typing. Yeah.
Yeah. I think there you go. Are you?
All right. Yes. All right. Great. Yes, we can see it now.
Okay. So previously, I told you to give me some research questions within environmental science. Anything you can, any occurrence you can make. And I told you probably there is something already done, a paper already published that using machine learning for that topic. And Chong SL make the question of dealing with lactic acid bacteria and enhancing the production of lactic acid using machine learning. And here you can see many related results for that topic. Let's see another question. Something is asking about, this is a classical one. Something is asking about deforestation. Predicting. I show you some examples, but however, since you make the question on the chat, I'm going to show you deforestation plus machine learning and see the results. 49,000, close to 50,000 results, and see the titles: considerations for selecting machine learning techniques for predicting deforestation, use of freely available data sets and machine learning methods in predicting deforestation, and so on. Let's see some other questions you have. Okay,
do you want me to read the question? All right.
Yeah,
actually, all right. There's actually a question from the participant. His name is Jason Lee, and the question is, what platform do you usually use for developing your model?
Can you repeat? Excuse me.
All right. The question is, what platform do you usually use for developing your model?
What
platform do you use?
What platform?
Yeah.
What platform?
Platform, yes. Yes.
Okay. I usually, well, you know, the data science steps go from collection to model deployment. So I usually use for my research questions, at least, I download a lot of data from satellite missions, like, let's say, ocean temperature. I use Copernicus for that. I use Global Ocean for that. Then I pre-process the data using R, let's say tidyverse, the tidyverse package, or the data R package, or the dplyr package. Then after pre-processing, after data cleaning, I can move also in R to some packages for specifically for machine learning. For example, the caret package or the neural net package. But other times I prefer Python. For example, TensorFlow, the TensorFlow library, which is very versatile for neural networks, for training neural networks. I forgot to mention that I also use SQL for making queries before using the data for prediction. Once I have the predictions, I try to make nice plots and nice summaries of those predictions, also using R, using Tableau. And basically, that's what I use. I mean, you can of course find many platforms, but if I make you a list of the ones I use more is SQL, R, Python, and Tableau.
Okay, I think that's the answer for Jason Lee. All right, the second one is from Afifa Hassan. The question is, what are the challenges that you face when developing model for environmental fields and how you encounter it?
Okay, many challenges, but I'm going to point out to probably two of them.
All right.
Despite the lots of environmental data that I show you that is being produced every day, that is not evenly distributed around the world. So, for example, in the place of the world that I worked, that is the Pacific Ocean of Colombia, the data is still very poor. So the equity of data being produced around the world is something that needs to improve, because there's a lot of data, let's say for the United States and surroundings, for Europe and surroundings, also for China and surroundings, right? Available, open access, free, really big data for environmental research. But for other countries and other regions of the world, let's say in the poor countries, data is still really poor. And that's an issue that needs to be improved in order to guarantee the equal access for environmental scientists. Okay, the second one is model evaluation. Since the data is still, let's say, poor compared to, let's say, other rich data countries, model evaluation is difficult. It can take a lot of time to test, to perform, let's say, or calculate evaluation metrics, performance metrics, to decide which machine learning algorithm, which particular machine learning algorithm is better for a particular task, and that can take a lot of time, and really make you have a hard time to make a decision. I will say the third challenge is the application, because many machine learning algorithms are being produced, and sometimes they have a great performance metrics, but that doesn't move beyond. So we need to really develop application, let's say, mobile phone, smartphone applications to make that discoveries available for people, not only in the research paper, which is okay and which is necessary, but also developing applications to, let's say, people can use it, environmental authorities in charge of decision making can use it, right? But because if it stays on the paper, nothing happens. I think that those 3 challenges. There are many more, but so far I can mention those.
All right. All right. I think thank you so much. First of all, thank you so much to Dr. Benavides. I think there are no further questions at the moment, and therefore we would like to say thank you again. And we appreciate your informative and engaging presentation, Dr. Benavides. And I'm sure the insight on how machine learning solves environmental problems and promoting sustainable development through the use of data-driven and predictive models was very interesting. All right, thank you again, Dr. Benavides. All right, now we would like. All right, sure. All right.
Terima kasih semua.
Terima kasih, sama-sama. All right. Now we would like to take another group photo with all the speakers and attendees. We kindly ask everyone to turn on your cameras and pose for the screenshot, and please kindly be reminded to put on the IEEE photo background. All right, so if you are ready, our team would like to take the photos. I think we have a few paints here. Dr. Benavides, could you please stop the screen sharing?
Okay.
All right, thank you so much. All right. Okay, all right. So we are going to start our photo taking. So we have, I'm going to take 4 to 5 paints. Please put a smile on your face. All right, when I count down from 3, please make sure your camera is turned on and please pose a smile for the camera, right? Okay, ready? For the first paint. Right, here we go. 3, 2, 1, smile. All right, great. So we go to the next paint. All right, here we go. 3, 2, 1, smile. All right, so the third one. All right, 3, 2, 1, smile. All right, we go to the fourth one. 3, 2, 1, smile. All right, I think that's all for now. We have enough paints for the photo sharing, and thank you so much. So let us proceed. Ladies and gentlemen, before we conclude our summit, I would like to invite Azmi Linda Zainuddin, Technical Chair of IEEE Young Professionals Machine Learning Summit, to deliver the closing remarks. And Azmi Linda Zainuddin is a member of the Board of Engineers Malaysia, BEM, and an active volunteer for the Institute of Electrical and Electronics Engineers, IEEE, and is currently an executive committee member at the IEEE Young Professionals Malaysia Affinity Group. And her current research interest lies in the area of machine learning for space weather. Without further ado, I would like to welcome Azmi Linda Zainuddin.
Okay, thank you very much, Ms. Rufaida. Can you hear my voice?
Yes, it's very clear.
And yeah, thank you. And can you see my screen?
Yes. Yeah.
Okay, thank you very much.
Right.
Okay, so so for the closing remark, I am Azmi Linda Zainuddin, a senior lecturer from Universiti Teknologi MARA, Campus Pasir Gudang, and I'm also the technical chair for the IEEE Young Professionals Machine Learning Summit and the executive committee for the IEEE Young Professionals Malaysia. And also a member of the Space Science and Engineering Research Group, Universiti Teknologi MARA, Campus Pasir Gudang. So this this summit is a collaboration with the Space Science and Engineering Research Group, Universiti Teknologi MARA, Campus Pasir Gudang, which is led by Dr. Norhani Kaswan, and also Dr. Muhammad Ashraf. So we would like to thank the Space and Engineering Research Group for collaborating in this summit. And I would also like to thank to our guest of honor, which is IR Dr. Nordin Ramli, the chair of IEEE Malaysia section, for giving the opening remarks. So I know that we know that he is very busy, but Alhamdulillah that he managed to make time for our event. Thank you very much, Dr. Nordin. And we would also like to thank our speakers, which is first Dr. Stephen Lotz from South Africa, and which he is also actually one of my experts. And the next speaker we have Ms. Mardiati Muhammad Yunus, and also Dr. Felipe Benavides. And thank you very much, because how I met Dr. Felipe is actually I came across his paper on data imputation using R. So it's an interesting paper, and which I think that Dr. Felipe should share it. Yeah, okay. So across the talk, we can see that how machine learning can be used across various of field, and also from users, which experts in codings and also in machine learning, to the non-technical people, which I mean like non-expert in coding and machine learning. So this is what's interesting about machine learning. And next, next, I would like to thank to all of the participants for your engagement. Okay, we received actually 470 registrations from across the world, and we can see that we have from Algeria, Bangladesh, China, Colombia, Cyprus, Egypt, India, Indonesia, Iran, Iraq, Libya, Malaysia, of course, Morocco, Nigeria, Pakistan, Somalia, Sri Lanka, UAE, United Kingdom, and also Uzbekistan. So thank you very much to all of the participants who turned up today, and also for your engagement and the questions given. And lastly, I would also like to thank the committee member who have worked hard for this summit, the general chair, which is Dr. Harun Rashid, and my technical co-chair, Ms. Sulastri Abdumana, and our IEEE Young Professional Executive Committee, which is Sarah Iqbal, and our Master of Ceremony, Rufaida Uthman, and our Dua reciter, Muhammad Zulkarnain Muhammad Nasir, which wasn't able to enter the Zoom because of a few technical issues, but it's okay. And we have our publicity lead, Zatul Ifa Abdul Latif, and design lead, Mayamin Yohanes, and also design support, Dr. Noropida, and our technical support, Dilis Chong Wen Wei, and lastly, our technical support, Nick Zuliani, Nick Kadir. So our committee members are inclusive of various background, and most of us are actually postgraduate students. And we have one from IEEE Young Professionals Ambassador. So thank you very much to all of the committee members who have worked hard for this event. And lastly, I would like to welcome everyone to like, follow, and share, and subscribe the IEEE Young Professionals Malaysia, Instagram, Facebook, link, our Telegram group, YouTube channel, LinkedIn account, and Twitter, and also we have this Clubhouse. So if you have any question or regarding the IEEE Young Professionals membership, and you are interested to be one of the ambassador, you can email us at the IEEEYPMY@gmail.com, and kindly visit our website for more information. So I think with that, thank you very much to everyone, and thank you very much, Ms. Rufaida, and back to you. Assalamualaikum.
All right, thank you so much, Linda, for the closing remarks. Ladies and gentlemen, we have come to our last event for the IEEE Young Professionals Machine Learning Summit. I, Rufaida Osman from Universiti Malaya, would like to apologize for any flaws while handling the ceremony. Nonetheless, I would like to extend our gratitude to the technical chair and all the organizers for making this summit a success. We have covered a diverse range of topics today, including a keynote talk on the rise of machine, a technical talk on machine learning in radiomic study titled A Way to Explore, and another technical talk on machine learning for environmental problems and sustainable development. I hope you found this summit insightful and valuable in expanding your knowledge and building connections within the industry. And again, don't forget to follow the IEEE Young Professional Malaysia Facebook, Instagram, and YouTube channel for upcoming interest events. Just search for IEEE YP Malaysia on the social media platforms. And thank you again for attending, and we hope to see you at the IEEE Young Professionals future events. Thank you.
Hi, do you know why we should engage with IEEE Young Professionals early in our career? Well, what is IEEE Young Professionals and how can it help us? IEEE Young Professionals is an international community of enthusiastic, dynamic, and innovative members and volunteers. Any IEEE member can be a young professional, and any member who received their first professional degree within the last 15 years is automatically considered a YP. Now, IEEE Young Professionals is bigger than you may think. It is one community in 10 regions across 183 affinity groups and more than 120,000 members around the world. So, why should we engage with IEEE Young Professionals, you ask? It is a place to connect and network with other professionals, enrich our career and personal lives, and participate in social events and activities. We can participate in many professional networks such as IEEE Collaboratech, IEEE email account via Google Apps, and take part in local meetings and online activities such as conferences and job fairs. We can also access the IEEE Center for Leadership Excellence for on-demand content. This really is an excellent resource to equip us with professional development skills. The benefits go on and on, particularly for young professionals early in our career as well as students. We can enhance our technical skills by accessing ebook classics, IEEE member digital library, Spectrum and Potential magazine, IEEE Explore, conferences, and more. Look, the bottom line is this. We can participate in exciting local events and global webinars for topics such as assessing emotional intelligence, fundamentals for leadership and ethics, heroes networking for engineers, survival guide for scientific writing, conflict management, negotiation tactics, and others. For all these great reasons, engaging with IEEE Young Professionals may be one of the best decisions that we can make in our personal lives and professional career development. That is why we should engage with IEEE Young Professionals.